Good morning, everyone. Good morning, everyone. Distinguished guests, esteemed speaker, delegates, and participants. It's my pleasure to welcome you all to the second day of the technical session of International Conference on Emerging Trends in Technology and Management, ICETM USA 2025. We are truly honored to host such an inspiring gathering of researchers, industry experts, academicians, and thought leaders from around the world. This session marks a key component of our conference where innovation meets application and theory meets practice. As we all know, fields of engineering and technology management are evolving rapidly, and in the forums like these that help us stay at the forefront of knowledge and development. Our goal today is to provide a platform where brilliant minds can share pioneering research, engage in insightful discussions, and spark collaborations that may shape the future of our industries and societies. We are privileged to have with us our session chairs, Mr. Satish Kumar, who is an IEEE senior member, accomplished researcher, and senior cloud infrastructure architect at Amazon Web Services with over 12 years of experience in IT industry. He has authored more than 15 peer-reviewed research papers and actively serves as a reviewer for leading journals and conferences in artificial intelligence, machine learning, and intelligent infrastructure. Mr. Satish holds dual master's degree in computer science and business administration, along with 6 AWS certifications. His core expertise include cloud automation, infrastructure modernization, and large-scale cost optimization. We welcome you, sir. We have also been joined by our next other session chair, Ms. Aditi Dokania, who is Director of Infrastructure, DevOps, and Security at Kensho Technologies LLC, an S&P global company with nearly 15 years of industry experience. She specializes in building scalable, resilient technology systems. A machine learning and AI company in the fintech space thrives on agility, and Ms. Aditi contributions help ensure operational excellence at scale. We welcome you, ma'am. Without further delay, let us begin the exciting session. And now I want to invite our first speaker of the day, Ms. Sayuri Shelley, to present her paper. Aditi, Anjali. Slideshow. So we welcome Sayuri for the paper, paper ID 343. And title of the paper is Flora RAG, Enhancing Conversational AI with Retrieval Augmented Generation for Floriculture. This paper is also co-authored by me, Dr. Garima Agarwal. We both are from Amity University. We are starting with this paper. Rapid advancements have seen in conversational AI and LLMs in the past years, which are revolutionizing how we interact with machines. RAG has been such advancement that enhances factual correctness by retrieving external knowledge on subject matter and ensures that data retrieved is up to date, factually correct, and derived from the reliable resources. It is exceptionally well known to upgrade the model's capacity to produce exact factual knowledge by considering contextual information from external datasets. RAG models have proved to improve relevant information obtained from various external knowledge bases and appear to significantly improve the performance of various natural language processing tasks. This paper presents Flora RAG, which is a model enabled with retrieval augmented generation for floriculture domain, giving a multimodal output of image as well as relevant text information, such as scientific name, habitat, appearance, etc., which might be relevant to the interest of the users. Let me walk you through the milestones in the evolution of RAG-based models. Let's start with RAG 2020, which introduced the retrieve and then read approach. It retrieves the relevant documents using a user query, then generates a response using both the query and the retrieved content. While impactful in grounding responses, it was limited to text data only. Next, we come to Retro 2022, which improved retrieval precision using chunk cross attention. This allowed models to focus more effectively on document segments. However, it was still used mainly for large scale, open domain, QA, and lacked support for multi-model inputs like images. Then in 2023, Replug arrived. It treated language models as black box boxes and focused on optimizing the retrieval instead. This made integration with existing LLMs easier, but again, it was text-centric with no visual reasoning capabilities. Finally, RAG 2024 pushed the RAG towards domain-specific tasks. It added reasoning chains to improve factual accuracy, particularly in the field of medical QA, but even RAG focused purely on the textual data. While RAG models have come a long way, there are still ways of critical limitations, especially when we try to apply them to domains like floriculture. First, these systems are largely designed for text-based systems. There has been no significant effort to align text with images or to support multimodal reasoning, which is crucial task for the tasks like flower identification, where visual understanding is important. Secondly, there's a lack of visual representation. Most RAG models generate responses using only the text. This is a major gap in the domains that require image-grounded outputs like describing flower features with the images. Thirdly, even though models like Reddit and Instruct Retro introduce dual instruction fine-tuning to better align the retriever and the generator, these advancements are limited to high-resource fields such as biomedicine, where large annotated datasets are available. Lastly, domain adaptation remains a major hurdle. Most modern RAG models need vast, well-labeled data to perform well, and that's not feasible in case of low-resource domain like floriculture, which often lack massive datasets. These limitations clearly highlight the need for a more domain-specific and multi-model RAG solution. The primary object of this paper was to develop a domain-specific model for floriculture, which is enabled with RAG, giving a multi-model output of image as well as relevant textual information such as scientific name, habitat, appearance, which might be relevant to the interest of the user. Yeah, next I want to hand over the slides to Ms. Sayuri to describe the proposed methodology of the proposed work. Yes, up to you, Sayuri.
Thank you, ma'am. Good morning, everyone. I will be taking you all forward with the presentation. Next, we have the methodology. The proposed methodology involves two main stages, retrieval and generation. The stage one is retrieval. The data set is gathered from scratch for 50 unique classes of flowers. It follows a GitHub-based data pipeline to fetch the image and textual data, such that each of the textual entries have been associated with metadata for retrieval and indexing. Then we have user query encoding, in which semantic vector representation is generated after passing input text query through query text encoder. For multimodal embedding, the textual descriptions are tokenized, images are divided into patches, and passed through self-attention layers of transformer-based text and image encoders, that is ImageBind, thus generating embeddings and linearly projecting them in a vector shared space. Embeddings are stored in kdb.ai vector database that supports high dimensionality similarity search using ANN, that is approximate nearest neighbor algorithm, retrieving the top k most relevant image and text pairs to query vector. Stage 2 is generation. In this, Gemini 1.5 Flash model uses transformer decoder architecture to process the query, textual and visual data fed as context and its own pre-trained knowledge. Further, system produces structure, domain-specific response, that is flower name, scientific name, symbolism, habitat, along with a relevant image that may be useful for a user. Next, we have the results. We observed that the RAG framework integrates KDB.ai for fast, high-dimensional vector search, improving retrieval efficiency and contextual relevance. It generates accurate, factually relevant responses in floriculture domains with multimodal output generation and semantic search. Thereby, the system outperforms vanilla Gemini in query processing and multimodal output generation. Coming to analysis of the model, Flora RAG is built using a robust and scalable AI toolchain. We used Python. Along with that, Hugging Face transformers were used for encoding user queries and generating high-quality embeddings. Meta's image bind enabled us to embed and align images with text into common semantic space, which is crucial for multimodal processing. Facebook's FAISS, that is Facebook AI Similarity Search, powered the approximate nearest neighbor search, enabling high-speed retrieval of relevant vectors. KDB.ai acted as the backbone vector database for indexing and storing high-dimensional embeddings. Gemini 1.5 Flash was a multimodal large language model used for generating the final context-rich response. Talking about how system performs in real conditions, we observed high retrieval precision for image text matches using cosine similarity with image bind embeddings. There was low latency thanks to FAISS and GPU support. Query resolution was nearly instantaneous, just around 150 milliseconds. GPU acceleration enabled faster vector embedding, storage, and inference, making the system scalable for real-time usage. Human evaluations showed that Flora RAG's output was significantly more competent and domain relevant compared to a baseline Gemini-only model. From a research standpoint, Flora RAG contributes to the broader study of domain-specific AI. It proves that RAG models can be successfully adapted to specialized fields like floriculture. We validate the use of multimodal embeddings, showing how tools like ImageBind can align visual and textual data effectively. By integrating retrieved knowledge, it helps reduce hallucinations in LLM outputs, improving reliability. Apart from theoretical knowledge, this system has real-world usability too. Flora RAG can work as an educational assistant, aiding students and enthusiasts in learning about flowers. There is strong potential for integration into agri-tech platforms and nursery management tools. It can also enhance e-commerce experiences for plant-based products such as. With that, I would like to thank you all for giving us your time for this presentation, and we are open for any question answers.
I think we have lost connection with um, Dr. Garima.
Sayuri, you can come to the conclusion slide, please.
Should I be presenting it now?
Just give me a minute. Mobinji, please give me rights to share the screen.
Ma'am, you have access. You can share your screen, ma'am.
Yeah, got it. Thank you. Sayuri, is it visible to you?
Yes, ma'am.
It is visible. Dimple.
So please come to the conclusion slide.
Okay, I'll start again. So now we are at implications for this model. From a research standpoint, FLORA-RAG contributes to the broader study of domain-specific AI. It proves that RAG models can be successfully adapted to specialized fields like floriculture. We validate the use of multimodal embeddings, showing how tools like ImageBind can align visual and textual data effectively. By integrating retrieved knowledge, it helps reduce hallucinations in LLM outputs, improving reliability. Apart from theoretical knowledge, this system has real-world usability too. FLORA-RAG can work as an educational assistant, aiding students and enthusiasts in learning about flowers. There is strong potential for integration into agri-tech platforms and nursery management tools. It can also enhance e-commerce experiences for plant-based product searches. With that, I would like to end our presentation and thank you all for your time. I would like to take up any question answers if there's.
Thank you so much, Sayuri.
Thank you.
Session chairs, any questions, please?
Yeah, first of all, thank you for a great presentation here. Yeah, it's a great to see that we moving from text to the image. Have you seen any improvements in the accuracy between the text versus image?
Yeah. Basically, the accuracy has been improved in this way that the output that we are getting it from the machine, we are getting image as well as the text. So if we want any information about a particular image, we are getting text also so that we can go into the details of that image. So this is a major advantage for using this RAG model for floriculture domain.
So that helps the users to
Yes.
confirm in both.
Yeah, scientific name, their species, their breed, so you can confirm from that. Thank you. Thank you, Sayuri.
Thank you, everyone.
Thank you so much. And let's look forward for the next presentation by Ms. Aditi Dokania on the topic improving diagnostic accuracy in telemedicine using image processing and pattern recognition techniques. We welcome you, ma'am. Yes, Aditi ma'am, over to you, please.
Hello, everyone. The author Ruchi mentioned here couldn't make it, so I'm presenting on behalf of her. My name is Aditi Dokania, and I'll be presenting about improving diagnostic accuracy in telemedicine using image processing and pattern recognition techniques. Next. All right. So let's dive in. Telemedicine overview and evolution. It provides remote access to medical services for patients anywhere in the world, increases convenience, accessibility, and cost effectiveness. It's evolved from simple audio-video consults to full digital diagnostics and treatments today, and leverages diverse digital devices and platforms for continuous monitoring. It has also formed the foundation for integrating advanced analytics and AI. And as we've seen during COVID, actually, this was really, really sought after because people could not really go and visit, doctors. And go to the next slide. Diagnostic challenges that we see in this process is ensuring accurate diagnosis without a physical exam, reduces human error by standardizing visual interpretation, prepares data for downstream pattern recognition and algorithms. And all of this is data that is collected by the medicine online so that you can keep this data for future recognition, etc. Some of the literature review. Telemedicine removes physical proximity, limiting key examinations critical for many diagnoses. Conditions requiring visual evaluation are especially vulnerable to misinterpretation. Variability in image video capture degrades clinical detail. Lack of standardized imaging protocols leads to inconsistent framing, lighting, and file formats across providers. So there is less consistency. Image quality and transmission barriers. So low resolution cameras, poor lighting, reduced contrast and obscure subtle findings. Network compression and transmission errors introduce noise, distortion, and frame drops. Absence of unified guidelines for medical image capture in telemedicine exacerbates inter-site variability. And clinician training in remote image acquisition and interpretation remains uneven. So talking about our methodology and the construction model, the image acquisition was done through remote capture of clinical images via telemedicine devices in low resource settings. We did some pre-processing of the data. We enhanced the contrast, etc. Did some noise reduction, median filtering, denoising, etc. We segmented the data, so automated isolation of regions of interest using thresholding, edge detection, deep learning, or delineate lesions or anatomical structures. And we did some feature extraction. So derivation of quantitative descriptors from each ROI to capture disease relevant patterns. The operating model that we followed, secure portal enabling real-time sharing of processed images and preliminary results among remote clinicians. Integration of patient metadata with image-based classifiers, outputs to compute risk scores, and real-time decision support, so continuous monitoring of the incoming data streams, trigger thresholds that alert providers to high-risk findings. And there was a feedback loop, ongoing incorporation of clinician corrections, new labeled cases to retain classifiers, and improving accuracy over time as we went on. So this is a little bit of a flowchart of how the process went from the training data and how the test data was incorporated into finding what the results and the images said. Some of the results we saw, the spatial domain filtering suppressed over 30% of the background noise, improving image clarity. Enhanced signal to noise ratio led to a 25% increase in clinicians' correct identification of subtle abnormalities. So there was a human in the loop involved in this experiment. Blind expert review reported higher confidence scores for noise-reduced images. Pixel level noise suppression before and after filtering, improved image quality, accelerated downstream feature extraction. So we used the deep learning model, achieved 90% overall accuracy with 88% sensitivity and 92% specificity on test set. Augmentation and normalization boosted model robustness. The key features drove pattern recognition performance. Learning curves show stable convergence within 50 epochs. And we got an accuracy of 0.94, which was excellent and discriminative. So this is some of the results and the comparisons that we did with the various different models. In conclusion, integrating electronic health records provides real-time, accurate forecast of patient outcomes and hospital resource needed. A robust pipeline of data ingestion, cleaning, and feature selection ensures high-quality inputs. Advanced machine learning methods, including neural networks, effectively model complex EHR datasets. Continuous concurrent model updating adapts prediction as new patient and operational data arrive. Precise forecasting empowers care teams to make proactive, informed decisions, and real-time insights into patient trajectories and capacity utilization drive efficiency and cost savings. I want to thank all the references that helped us do this research, and thank you.
Thank you. Yeah, it's a very relevant topic, especially in 2025 with all the AI stuff. Based on your research so far, how close we are, like, avoiding that physical doctor appointments?
I think far away. Not far-fetched, obviously, but there are, like I mentioned, there are critical treatments that are still require physical examination by the doctor, at least diagnosis-wise. It's a matter of time, though, that people will be able to do this image processing and things like that and get solid feedback. But I would say at least 5 to 10 years from now, we can.
But definitely, I think it's definitely
coming.
the existence for the doctors, right?
For sure.
Just like double checking thing, right? Maybe they always look into the documents or the ultrasounds or anything.
Yeah.
So, but this will assist.
It'll assist a lot.
Assistant that will help doctors to take a correct decision.
Yeah.
And avoid the mistakes and all.
Yeah, exactly. It'll definitely form an assistant even today. Actually, I feel like there are a lot of companies coming out which are doing this assistance for doctors. I feel like that will come sooner. But if you say that the complete avoidance of visit to doctors, that's going to take time.
Yeah, but the actual looking at the documents and all the scan
Yes.
reports and all still manual, right?
Yeah, it
As
is
of-
manual.
Yeah.
There are EMR systems, EMI systems that people do a lot of, but they have to enter it manually. Yeah. Thank you all.
Thank you so much, Ms. Aditi, for presenting a wonderful paper. Next, I would like to invite Ms. Drishti Idnani. She's going to present her paper on exploring human capital depreciation and gender-specific wage trends. And she has taken the case study from Italy. We welcome you, Drishti. So over to you, Drishti. Thank you. You can start. Okay.
Thank you all for this wonderful opportunity and good morning. As ma'am said, I will be presenting my research. Oh, it's not connected.
Yeah, it was.
Thank you. Good morning. Uh, Good morning, all. I will be presenting my research paper, as ma'am said, exploring human capital depreciation and gender-specific wage trends, which is evidence from Italy. This research is supposed to examine how human capital depreciates as we grow and depending on both our education as well as when we get our gender aspect into it, then how does that affect our depreciation and appreciation into it and into our capital accumulation over time? As we've noticed, there is a gap in understanding how wage trends actually affect both gender specific aspect to it. So we have taken our data set from an Italy based data set that takes sorry, that is supposed to take people that were working from 1980 to 2020. So they were born from 1940. So this analysis reveals a distinct pattern in human capital depreciation rates across both education and eventually when we bring in the gender aspect and gender. We take our Ben-Porat model, which was supposed to be a framework that linked wage growth to human capital depreciation and accumulation over time. This model incorporates factors with both depreciation rate, productivity parameters, and age. The research gap that we did notice, as I said, was with human capital evolution among individuals, with both varying education levels as well as with gender-based disparities. Our research aims to divide it into cohorts, divide our data set into first cohorts, and then bring in the gender aspect to realize and understand whether it actually affected our our wage trends or not, so that it is an absolute analysis and not just that, hey, gender was the only disparity or the only trend that affected it. Our research gap and objectives. So we asked two key empirical questions. First, what are the returns to human capital investment across different education levels? And secondly, are there significant gender-based disparities? First, as we said, that our first objective was to analyze what are our key investments into education and growth. And second is to get in the gender aspect into it. The study aims to address these questions by both examining wage age profiles and then depreciation across education levels. The Ben-Porat model, or the model that we brought in, predicts that higher the human capital, more we invest into our education, leads to faster depreciation over time. However, that actually means that more educated individuals do earn more, but we also face quicker skill erosion over time. So less educated workers see faster growth earlier in their career, but slower growth later on in their career. More educated individuals see slower growth early on in their career, but faster growth later on in their career. Going on to methodology and identification strategy. As I said, our data set was from Bank of Italy's Family Income Survey, which had over 100K observations covering from 1980 to 2020, which had individuals from 1940. Our model was a basic regression analysis, which had a CEF, so conditional expectation function, examining the relationship between log wage and log hours and independent variables like age square, cohort, and years. We obviously had some control variables like age, like middle school, high school, all of those control variables, and we had an analysis to bring in various aspects of it. Now, our key findings, as I said, firstly, we wanted to not bring in the gender aspect of it. So we realized, as we can see here, that with education, as we grow, the more you invest in education, the better returns we do get. So that has been our understanding of growth anyway. Even 1 year age increase yields 11% increase rise as compared to like 12.6% for highly educated individuals. However, when you were just to bring in the gender aspect of it, you can actually see the difference between male and female education versus gender gap. So even if they were educated the same level, you know that they're not gonna get the same level of appreciation irrespective of what level of career they're in. That. Now to analyze what is actually causing these gender disparities, irrespective of what stage of gap or stage of career they're in. If they're in early career, we've seen that women who join, like less educated women who join their career in or start working earlier on, they usually have to reduce work hours post childbirth. So they've joined their work earlier on, so they started working earlier on, they're paid lesser, but also have to stop working or faster or sooner because childbirth. More educated women have to start working later on, but also postpone childbirth and have to slower on later on. Overall, women not only have to work fewer hours, but also have to balance more when it comes to home, having to balance work at home. They also get to invest less when trying to develop more skills as they go on to having to increase their skills as technology develops, as skills develop or skills needed to be developed. So education effect and late career is another aspect of it. However, we've also seen that as we grow, as after the age of 50, gender disparities actually persist, but narrow slightly after the age of 50, because there's lesser of managing things at home, there's lesser of kids and things to manage at home. So it has decreased then. But we have seen that overall women do have to face lesser growth, and the annual gender gap is almost at 1.2%. And this is just specifically to Italy, as we know the data is specifically for Italy. So yeah, analysis and implications. We do know that this has deep implications, and we should address these gender discrimination in both labor markets and the societal implications, because there are unequal returns despite similar qualifications, similar education levels, despite higher education yielding better returns, and gender impacts being present. So policy must go beyond just education. There should be issues to it. There should be policy issues addressing caregiving burdens. There should be policy issues in addressing workplace flexibility. Our findings do support the need for inclusive growth and growth strategies. These insights highlight the critical role of education in the labor market, irrespective of gender, but also the need for policies for addressing broader factors, including discrimination and family responsibilities. Our key conclusion is that the study confirms the gender wage gap, which has been present over time due to both unequal returns on human capital investment and women receiving lower returns despite similar qualifications. The limitation has been, or at least the model limitation has been, firstly, this is just limited to Italian data, which is obviously not going to be enough to derive this analysis. Secondly, this only had data from 1980 to 2020. Obviously, we've come far, far from that. So this needs to include more data. And it does not address for factors like discrimination. It does not address for factors like what kind of policies every country or every continent has. So none of these non-technical factors were addressed in this model. Future research should incorporate broader factors like these, especially family responsibilities, especially wage disparities, and how to mitigate these inequalities. Yeah. Thank you. Any questions?
Yeah, I wanted to know about the sample size, like was female and male represented equal? Like, can you describe your like 100K sample size?
It was almost like, I want to say 65, 35 more because I want to say not even 65, 45. I'm going to say 70, 30 more because it's never going to be equal. It's always going to be skewed because
But did you normalize that? And did you take that into
we
account?
we did take that into effect. We did not normalize it because we wanted to take that aspect into it also. So we did not normalize it, but we did take that into effect. Yes.
No, it is a prevalent gap.
Yeah.
But the study and the research will only make sense if we actually compare apples to apples, right? Like we say
Yes.
that women in a workplace is fewer. Can we take that same data? And it's hard research, but
Yeah.
Good one.
Thank you.
Yeah, I have one.
Yeah.
So, is there any specific reason you go with Italy instead of like other countries? I know you might not have answer, but just curious question.
No, it was actually just a bigger data set that was available. So this had like 100K observations. Most countries do not actually have that predated data set. So that was the reason. And going back to 1980 was a huge thing that kind of put me.
It's hard to apply like country like India. Like
Yeah, I mean, India, not as much, but even with US, not a lot of women were even allowed to work or had credit cards of their own until for so long. So even that was important. I think European countries are the bigger market for where women used to work for like 40 years ago. So that was my main target for this. Yeah.
Great.
Thank you. Thank you so much.
Thank you.
Thank you so much, Trishti. Next, we have with us Ms. Shruti Sarkar, paper ID 27. She's going to present her paper on optimizing cost benefit efficiency of gender responsive AI voice agents for enhanced small and medium sized business operations. We welcome you, Shruti. Shruti, it's over to you, please. It's visible? Yeah, visible. Right?
Good morning, everyone. I'm Shruti, and I'm so grateful and thankful to be able to present this paper on behalf of my amazing team of researchers from institutions across India and US. So today we are going to be diving into the topic of optimizing cost-benefit efficiency on gender-responsive AI voice agents for enhanced SMB operations. We are going to be reviewing this presentation into 8 parts: the introduction, the literature review, research methodology, how the AI voice agents work, and the comparative provider analysis, cost saving, the benefits, and the challenges that the SMBs face. The introduction. So the small and medium-sized businesses are the backbone of any economy, but they frequently encounter constraints in delivering the round-the-clock customer service 24/7 due to limited budgets and human resource availability. Gender-responsive AI agents, whereas, have emerged as a solution offering consistent, scalable, and cost-effective communication channels. With advances in NLP, the natural language processing, and machine learning and speech synthesis, these agents now replicate human-like interactions. Despite theoretical advantages, there remains a need to empirically assess the actual cost savings, implementation feasibility, and operational effectiveness of AI voice agents compared to the human staff. In the next slide, we're going to see the literature review. This review discusses the theoretical and practical structures of how the AI voice agents work. The gender responsive voice agents combine the NLP, the natural language processing, and the speech recognition and machine learning to interpret what the customers are trying to say and give them an appropriate response. They replace the traditional IVR system, that is the interactive voice response, with conversational interfaces to make the customers and to make the interaction user friendly. The demand of the voice agents are rising in healthcare, retail, finance, and hospitality sectors. And we can see in the future, it can also be into the education sector. In the next slide, we have compared the quantitative data and the qualitative data of the AI voice agents. In the quantitative data, we have designed a cost framework comparing the AI versus the human receptionist cost. In the variables included, we are going to see the setup fee, the operational cost, the human receptionist salary, and the scenarios model. The setup fee of the AI voice agents can range from up to $1,000. The operational cost of the AI voice agents would be about $0.15 per minute. But whereas the human receptionist salary is $30,000 a year in the US. So we can see how much actually the SMBs can save through this data. In the qualitative data, there are benefits like there will be more customer satisfaction, there is reduced waste time, there is brand consistency, and no human-like error, and the gender responsive impact, which can make any customer comfortable. We're going to see how the AI voice agents actually work. Step 1, they actually listen to what the people are saying and they interpret it through the automatic speech recognition and convert it to text. In the step 2, the natural language processing interprets what the content of the customer said. In the third step, the AI determines appropriate response and selects a relevant response that they would like to give to the customers. And the step 4, they convert the text to speech and give a natural voice like reply to the customer so that they feel like there's a more human like interaction. Comparative provider analysis. There are a number of different AI platforms that provide this gender responsive AI voice agents like Air AI, Vapi AI, Retail AI, and Bland AI. The Vapi AI is the most strong as it has low cost and low latency, but provides high scalability and reliability. the overall efficiency of that AI is also really good. The cost savings. A human receptionist costs around 30,000 a year for an 8-hour shift and $90,000 a year for a 24 into 7, like 3 employees. Whereas in the AI voice agents, if we compare 4 cases, we can see we can save up to about $60,000 or $37,000 if the AI voice agents work 24 into 7. And in the case in case for 8 hours, we can save up to $16,000 to $12,000. What are the benefits of the AI voice agents? Apart from the operational cost savings, they are available 24 into 7 and they are reliable. They ensure brand tone consistency and reduce human-like error, and they are scalable to increasing workloads and can work 24 into 7. What are the challenges and ethical concerns of these AI voice agents? The initial setup and technical onboarding costs. Though some of the companies provide plug and play AI voice agents, but it is still a little hard for small and medium businesses to actually set up these AI, but it is more cost saving than the actual human receptionist. There are bias concerns in gender AI voices and data security and user trust issues. And there's also ethical debate on female voices enforcing stereotypes. Thank you. That's all. And thank you for understanding and time.
One question. Have you explored what are the tasks that they cannot do? Like what are some of the tasks that you call assistant that these assistants don't do?
That's a great question. I actually haven't looked that deep into it, so I'll.
Have you thought about we're comparing cost savings with human marketing, right? But is that anything based on your research? But it creates some unemployment as well, right?
Yeah.
So how far we are?
It can shift jobs because these things, the work that the AI voice agents do, they are repetitive. So if we shift jobs to and give them to the AI voice agents, the humans can, like, we can give the humans a more high technology or like high impact jobs rather than just repetitive calls all throughout the day. So
Interesting job.
yeah.
More interesting.
Yeah. Thank you.
Thank you so much. Next, we have with us Mohammad Firozke. We welcome you, Mohammad. He is going to present his paper ID 279, Smart City Sustainable Development, Modeling through Quantitative Analysis of Air Pollutants. He has done a case study on Chennai, India. We welcome you. Over to you.
Okay, good morning. Good morning, everyone. Okay, my name is Mohammed Firoz. I'm from ABS. So I'm here to present about smart city sustainable development modeling through quantitative analysis of air pollutants study. It's like a study based on Chennai. So a study on air pollution management and sustainable development. So we all know that air pollution poses a significant threat to urbanizing, mainly urbanizing regions, urbanizing cities. So it's like a major threat to the public health and safety in every city. So the main reason behind this pollution is particulate matters like PM 2.5. It's like a particulate matters like PM 2.5 and PM 10. So both of these are like pollution particles, which has a diameter of 2.5 micrometers, and PM 10 is like a diameter of 10 micrometers. So the study is based on Chennai. It's situated in state of Tamil Nadu, which is located in India. So it's like a urbanizing city, and it's developing day by day. So the statement research objectives, the study analyzed historical data on PM 2.5 and PM 10 levels to identify trends and patterns of air pollution in Chennai. So with these data, we developed a predictive model using SPSS software, that is statistical packaging for social sciences. And it helps to forecast the future concentration of PM 2.5 and PM 10 in the region. After analyzing these data, we assess the effectiveness of existing pollution control measures and propose targeted interventions based on the predictive analysis to mitigate the air pollution and promote sustainable development. So as a whole, to simplify it, the research aims to contribute to better understanding of PM 2.5 and PM 10 patterns in Chennai, and it improves the accuracy of air pollutant concentration forecasting and sustainable urban development and air quality management in Chennai. So if you talk about the research gap, there is only limited research on the predicting PM 2.5 and PM 10 levels in Chennai using SPSS software and linear regression analysis, because we cannot always get the linear equation because it's like it's a prediction, right? So we compared the pollution controls of major cities, and we compared to the Chennai's atmosphere, and we were able to like provide a linear equation for that. The significance of the study is like as I told before, it is expected to provide valuable insights for policymakers, urban planners, and environmental practitioners striving to promote sustainable development goals and mitigate the adverse effects of air pollution in Chennai. So the air pollution, particularly particulate matter, that is PM 2.5 and PM 10. These are the two most significant particulate matters that's leading to air pollution in many cities. Like PM 2.5 means like it's a particulate matter with a size of diameter like 2.5 micrometers. For example, like smokes and fire smokes and vehicle emission gases, like that. And PM10 is like mostly dust particles. So that is so the importance of historical data analysis. I just mentioned before that we used the past historical data of PM 2.5 and PM 10 levels to provide the prediction for the future, how the particles will behave. So historical data on PM 2.5 and PM 10 levels serves as a crucial foundation for the understanding the dynamics of air quality in urban environments. Analyzing historical data on PM 2.5 and PM 10 provides insights into the long-term trends and patterns of air pollution, informing policymakers and urban planners and environmental practitioners about the efficacy of existing pollution control measures and the need for additional interventions to mitigate air pollution. And these were done with the help of SPSS software. I'll explain with the methodology. So the first method for this SPSS software usage was data collection. So we gathered historical data on PM 2.5 and PM 10 levels in Chennai, and population at the same time population data to compare. And from reliable such as government census records, urban planning department, demographic surveys. So after the data were collected, we analyzed it through we did a statistical analysis to examine the distribution and variability of PM 2.5 and PM 10 concentration over time, as well as population growth trends in Chennai. So this predict, and after this data were analyzed, we did a predictive model using the SPSS software, that is the statistical package for social sciences. So we were able to establish relationship between the population growth and air pollutant concentrations. So employing statistical techniques such as linear regression analysis. So the results provides predictive equations for PM 2.5 and PM10 levels in Chennai. It allows for forecasting future concentration based on population size. The equations are like PM10 predictions y is equal to 400.478 minus 0.00002964x, and PM 2.5 y is equal to 178.6396 minus 0.00001349x. These equations were generated with the help of SPSS software. And as you can see here, this is like the PM level, and this is the population level. X variable is the population, and this is the Y variable, which is the PM level. So this is analyzed after the control measures were installed in Chennai. So as you can see, as the population is increasing, the PM level is increasing, which means the control measures are becoming effective. So, and we were able to form a linear equation with this equation I just said about, that is y equal to 400.478 minus 0.002964x. So similarly, this is for the PM10 particles, and this is for the PM 2.5 particles. So the implications for sustainable development, better understanding of PM 2.5 and PM10 patterns, improved forecasting accuracy. The predictive models always improves forecasting accuracy of both PM 2.5 and PM10 concentrations, allowing for timely public health alerts and response strategies. So sustainable urban development and air quality management. The findings support sustainable urban development and air quality management in Chennai, contributing to improved public health and environmental sustainability. So, as I mentioned before, the control measures, the steps taken by Chennai to control air pollutants were like vehicular emission control, industrial emission control, construction and demolition control, and waste management, public awareness campaign. So these steps align with the objectives of National Clean Air Program, which is launched by the central government in 2019. It is aimed to reduce PM10 and PM2.5 in 131 cities in India. So the policy recommendation, if I'm talking about the policy recommendation, the implication for Chennai, the study suggests that policymakers in Chennai can consider adopting strategies similar to those of successful cities like Portland, which is in Oregon. So it's like west of United States. And in these regions, they were like promoting public transportation and providing clean energy like CNG, LPG, and the most important thing I want to mention is that they were promoting cycling and walking, so that this kind of pollution are not there. Even traffic signal synchronization was also done in this kind of region. So cities like Chennai can adopt these measures to mitigate the air pollution in those areas. And another thing I can talk about is launching tree planting initiatives and setting ambitious targets for fossil fuel divestment and renewable energy adoptions, and implementing robust waste management and recycling systems. We can use, there are so many smart city technologies that can be used to monitor air pollution levels and manage traffic flow. So that's all I have to talk about. Thank you. So any questions?
I wanted to know, why did you choose Chennai?
It's because when they like this NCAP, National Program, launched by the central government, it has targeted 131 cities. Like 131 cities, the Chennai was also included in this, and it's very close to my hometown. So as a businessman, I used to travel in like northern part of India and southern part of India. I'm living in southern part, so as a businessman, I used to travel all these areas. So like I used to analyze all the like atmosphere of every city. So when I saw the like after this program NCAP was launched, the pollution control, like for example in Delhi, the pollution control was not that much attained. So I was able to see the difference. So even after the control measures were taken, some cities in some cities it was not like effective. So that's why I chose Chennai, because I was able to see the effectiveness, and it is very close to my hometown. So that's why I chose Chennai.
So it's I was not clear on that when you show that linear graph, right? So is that the population increasing, the actual
This is like
same?
not like this is like a predictive analysis. We used past historic data of PM 2.5 and PM 10 levels.
Right.
And we compared to all the cities. And this is like only a predictive analysis. Like, see,
The
this
population
is
is not
this is
increasing, or
it's
even though
decreasing. This is like the when the population is increasing, PM 30 is decreasing. This is because the control measures were installed in Chennai.
Okay.
That's why it's decreasing. Normally, if you say that when population increases, pollution decreases.
Right.
I got your doubt.
Got it.
This is because the control measures were
It's the control measures. Those are okay.
So because we were able to perform a linear equation, and it has some limitations because it's a prediction, right? It cannot be right all the time. Depends on the data we have
So
taken.
your predictive model help or assist them to
Yeah,
make
because
these control measures more even.
Yeah, sure. Because this like this is like a motivation for the urban policymaker, or like those who are planning to do sustainable development for mitigating air pollution. So they can use this data and they can like promote public health and safety through this.
That's good.
Yeah. Thank you.
Thank you, Firoz, for such an informative presentation. Next presenter is Mr. Avnish Sirohi and Mrs. Garima Agarwal, and the paper title is ColNet, a compact convolution transformer framework for automated colon cancer.
Thank you, Akriti. Good morning, everyone. Myself, Dr. Garima, and I'm going to present a paper on ColNet, a compact convolutional transformer framework for automated colon cancer prediction from endoscopy images. I have also been joined by my co-author of the paper, Avnish Sirohi. Avnish, slides are visible to you?
Yeah, it's visible.
Okay, thank you. So we both are going to present this paper on about compact convolutional transformer framework for prediction of colon cancer. Colon cancer is one of the most causes of cancer-related deaths worldwide, and recent developments in deep learning introduce automated diagnostic systems with convolutional neural networks and vision transformers, and both are playing a significant role in cancer detection. However, they struggle with the capturing long-range dependencies because VITs require large-scale datasets, which make them less suitable for medical applications with limited data. To address these challenges, compact convolutional transformers was introduced as a hybrid solutions that combines the working of both CNN and transformers. CCTs integrate convolutional layers for tokenizations, which improves feature extraction before feeding the data into transformer models. So earlier, the concept of CNN has been used, in which the combination of convolutional layers, ReLU, pooling layer, flattening dense layers has been used, and they are successful in detecting the local features like edges, textures, and patterns. But inspired by the transformers in NLP like BERT or GPT, instead of using convolution to learn local patterns, vision transformers treats images as a sequence of patches. They basically, it is similar to that how words are going to be treated in text. They learn global context using self-attention. So latest related work has been done on CNN and VITs separately. So in CNN, I told you about the local feature detection like edges, textures, and patterns. Whereas in VITs, that is vision transformers, image is divided into fixed size patches, and each patch is flattened and embedded into a vector. Addition to that, positional encoding has been done. Self-attention layers has been done to model the relationship between all the patches. So it will help to detect the global context because it helps in spatial arrangement of the abnormal tissues. So VIT is anyway better than CNN because VITs are basically used for global feature extraction because they are having the capability to capture long-range dependencies between distinct part of the images. They are also lead you to the better context understanding because they are useful for recognizing subtle tissue structures found in histopathology images. Attention mechanism offers basically interpretability. It will help you to visualize which part of the image influence the decision. And with access to large data sets, VIT outperforms CNN on accuracy. So these are the related work that has been done in the past on this topic. But now we have taken up a step forward approach. We have introduced the concept of convolutional transformers, that is compact convolutional transformers. It is a deep learning model that addresses the limitations of pure vision transformers, especially for smaller data sets, integrating convolutional tokenizers instead of row patch embedding. We have used the concept of sequence pooling to reduce the number of the parameters. We have retained the positional awareness and spatial structure better than the standard VITs. So this is the dataset that have been used. Dataset comprises of 768 cross 768 pixel histopathological images that has been sourced from HIPAA compliant repositories. Pre-processing starts with gathering the images, organizing them into data frames with labels, and inspecting for irregularities. Visualization help identify class imbalances, and the data is split into balanced training and validation data sets. Augmentation techniques have also been used, like flipping horizontally or vertically, and zoom random images are applied to improve the diversity and generalization. These are the labeled dataset examples for the benign and the malignant cases. Using TensorFlow.tf data API and efficient data pipeline optimizes processing initially containing 500 images of benign tissues, that is train test and test N, and then we are having adenocarcinomas, train ACA and test ACA. The data set was expanded to 10,000 images using Augmenter. So these are this is a figure that is showing a labeled data set with both the examples of benign and malignant cases. So over to you, Avnish. Please explain the model architecture, that how we have performed all the processing and how the different layers has worked in processing these images. Over
Thank
to you,
ma'am.
Avnish.
Thank you, ma'am. Good morning, everyone. I'm gonna explain the architecture of compact convolutional transformers. So the model's core lies in transformer encoder layers, which are responsible for multi-head self-attention and MLP processing. The architecture of CCT model is meticulously structured to optimize the process of image classification in colon cancer detection. Following the input layer, an augmentation layer is implemented using sequential model from TensorFlow. This layer applies transformations such as random flips, rotations, and zooms to increase the diversity and robustness of the dataset. By enhancing the variability of the training dataset, this augmentation mitigates overfitting and helps models generalize better to unseen data. The following key component is the CCT tokenizer, which employs a patch-based tokenization approach to segment input images to smaller patches of size 12 cross 12 pixels. This transformation results in sequence of tokens that represent the image, significantly reducing the dimensionality of input and enabling model to focus on local features. The output from this layer is then added to a positional embedding, which encodes the spatial information of patches, allowing model to maintain the relative positioning of features during processing. The architecture features several S1 transformer blocks that are pivotal for capturing long-range dependencies in the image data. Each block includes a multi-head attention heads, which helps the model to do selection on different parts of the image simultaneously. thus enhancing the feature extraction capabilities. This mechanism is essential for understanding complex patterns and relationships within the image, which are critical for accurate cancer detection. After the attention layers, each S1 transformer block integrates feed-forward networks, which comprises of dense layers, which are followed by activation functions such as ReLU. These layers allow for nonlinear data transformations, enriching the feature representation and enabling model to integrate patterns associated with cancerous lesions. The model incorporates dropout layers after dense layers to prevent overfitting by randomly deactivating a fraction of neurons during training. And finally, output of last one transformer block is passed through final dense layer with softmax activation function, producing probability distributions over two classes, malignant and benign classes. The softmax function is essential for multi-class classification tasks. Of, and as you can see in the slide, there is a demonstration of that architecture model. After that, in training, callbacks were defined for model training, including early stopping to prevent overfitting by halting training after no improvement in validation loss. Model checkpoints saved the best rates. The model was fitted on the training dataset and validated with performance metrics monitored and hypermeters adjusted to enhance performance. As you can see, this is a confusion matrix which was generated to analyze model's predictions, revealing 665 true positives, 35 false positives, 25 false negatives, and 675 true negatives. This visual representation helped identify areas of improvement in distinguishing between malignant and benign cases. And after that, we have this comparison table from existing ResNet, inception, exception, DenseNet. And as you can see, our proposed model has highest F1 score and accuracy of 97%. And we have 1.9 million parameters model. And here is the second table, which shows a comparison of existing architecture, and it beats VIT by 0.02%. And the specialty is it works on low GPU, so it's a kind of win. So in conclusion, this research presents a new method of predicting colon cancer using CCT, achieving 97.14% precision and F1 score of 0.97. With data set of 10,000 histopathological images, the model effectively distinguishes malignant and benign cases. With this proposed compact model, it is easy to deploy on server with small GPU, unlike VITs, and providing easy way to train on small data set. And here are the references.
Thank you, Avanish. Yeah, any question, please?
In the confusion matrix, you showed that there was one that was like falsely classified. Did we go deeper into what happened there? Like,
Just give me a minute. Avanish, we have classified one as falsely classified. Have you taken any measures for the same?
Currently, I don't have the image. Maybe there is. I have to check once. There must be
So
a.
basically, all the images have been truly classified, and one or two has been taken, and we will take care for that how it can be more accurately proved, because the overall precision accuracy that we have received from the model, that is coming out to be 97. Yeah.
no, it's good. Precision. I just wanted to know that one image, what was.
Yeah, that I need to see in the code. Thank you.
Is it quality is live or is that proposed?
No, this is just we have proposed. This is the work that is done by Avanish. He's an MTech student, so he has just completed this work, and then we will go it for the live. Yeah. Thank you. Thank you, Avanish.
Thank you, everyone.
Next, we want to call upon Yatharth Mendirata, paper ID 190, who is going to present her paper on analyzing video surveillance to handle traffic occlusion. We welcome you. Over to you.
Good morning, everyone. My name is Madhav Sharma, and today I'll be presenting our project titled Analyzing Video Surveillance to Handle Traffic Occlusions on the behalf of my team. This research focuses on using artificial intelligence and computer vision to monitor traffic in real time, especially in complex scenarios like occlusions. System overview. Our system leverages video surveillances and AI to track traffic every 10 seconds. It detects vehicles, estimates their speed, and stores the data. We continuously monitor and analyze urban traffic behavior. System core functions. System core functions basically works. System core function basically works on real-time monitoring, speed estimation, and data logging. In real-time monitoring, vehicle detection and counting contains every 10 seconds of continuous monitoring. Speed estimation, categorizing vehicles based on their speed. Categorizing vehicles means what type of vehicle they might be. They might be a two-wheeler, three-wheeler, a heavy loader like a truck or an SUV. And data logging. Data logging stores vehicle counts and speeds in MySQL database for analysis. AI and computer vision techniques. Vehicle detection, speed calculation, data analytics. Vehicle detection. Using background subtraction and contour detection. Vehicle detection uses background subtraction and contour detection to identify vehicles. Speed calculations tracks vehicle movement frame by frame to estimate speed in kilometer per hour. Data analytics generate heat maps, histogram, and line charts for traffic insights. Traffic scenarios and matrix. It depends on the type of traffic that we are having and the place where the traffic is situated. Light traffic, heavy traffic, occlusions, and performance metrics. Light traffics test systems accuracy with sparse vehicles, like on a regular day, non-office hours. Heavy traffic, like in a rash city during office hours. Occlusions. Occlusions are quite rare, but they do happen when any mishappening happens or the traffic lights are not working. Performance metrics includes detection accuracy, speed estimation, and FPS rates. Vehicle detection and counting results. Light traffic, 98% detection accuracy in sparse conditions. Heavy traffic, 92% accuracy despite vehicle occlusions. Counting trends. Daily vehicle counts show that clear traffic fluctuations. Speed estimation performances. Low speed vehicles. Speed estimate within 5 km of actual speeds. High speed, less accurate above 100 km per hour. Needs further tuning. Mean error, 2 to 5 km per hour error margin acceptable for monitoring. Now, traffic flow and data logging. Flow rate calculation. Real-time flow rates match ground truth data. Data logging. Vehicle count speeds stored every 10 seconds. Reporting. Daily reports summarize counts, speed, and congestions. Visualizing and analyzing. Traffic trends. Line charts show hourly vehicle count peaks. Speed distribution. Pie chart categorizes vehicles by speed ranges. Heat maps. Highlight congestion zones in targeted actions. AI traffic management. Process and results. Data collection. Captures vehicle images and speed data in real time. AI processing. Detects vehicle, estimates speed, and counts using computer vision. Data logging stores vehicle counts and speed data for analysis and reporting. Analysis and result generates insight on traffic flow, congestion, and speed distribution. Conclusion and future directions. The system effectively monitors and estimates speed in real time, improvements needed for high speed accuracy and occlusion handling. Future plans include advanced detection algorithms and IoT integration. That's it. Any questions?
Yeah, I have a couple of questions. So who's the targeted audience? Who will benefit from this? Is that for car companies or
No, it's not for car companies, it's for traffic management.
traffic management?
Yeah.
For like cities,
Yeah, right now it's based for cities because it depends on the speed cameras and traffic monitoring cameras, which cannot be placed in rural areas per se.
Right. It's not designed for like cars, right? Like Tesla.
No, it's not designed for that.
Yeah. And that was my question for like 10 seconds is too late, right? For that kind of thing. But for cities, I think 10 seconds is fine.
Yes.
Thank you.
Thank you, sir.
Oh, sure.
I did prepare that. I'm sorry, I'll answer you. So, thank you.
So, how usable is this in the real world, or like smart cities?
Like it's quite usable. It helps in traffic management. Like if you're going somewhere and like it's basically just Google Maps, but a bit of advanced version for that. Like when you're using Google Maps and it deroutes you from like it says that we have estimated a new route and it takes and diverts you and takes you from somewhere else. It basically is similar to that, but here it would actually help real time. Like it often happens that in Google people fake report and it shows that there are multiple people using that roads and stuff, but in this way the traffic monitoring is on cameras, not on satellite versions. Hope I answered your question. Thank you.
Thank you, Mr. Madhav, for an amazing presentation. Next, I would like to call upon Mr. Rahul Autare to present his paper titled Computer Vision for Financial Fraud Prevention Using Visual Pattern Analysis, paper ID 363.
screen you're sharing. It's not going on that screen. It's not presentation. Sorry for technical issues, guys. My name is Rahul Otade. I'm here to present a paper which has been collaborated with my colleague, Himangi Bindu. Could not be here because of her work commitment. We're here to present a paper regarding the computer vision for financial fraud prevention using visual pattern analysis. The paper ID is 363. So our paper is based on the current market rate. So all the currently the financial institution going for the digitalization, all the faster payment, real-time payments. So while doing so, the fraud catch is also important factor in terms of the government sanction regularities and also for the customer protection basis. So this is where we are doing it right now. Along with that, when the industry is going faster payment, we also make sure the fraud which are on the image based, not the database, but mostly image based, which are undervalued. We want to focus on that factor. So let's go into that introduction, right? Yeah, as I said, currently the financial fraud is one of the growing global threat. As per data analysis, we lost trillions of dollars in last couple of years globally in terms of the financial fraud, whether those are data-based or vision-based. So the current market or the current conventional technique we have, those are mostly rule-based and the database. We use the tabular data and the structured data, which is more focused on. But currently, there are also the more sophisticated fraud is happening, which are image-based. So current technique are not sophisticated. I'll not say there are not techniques. There are techniques, but those are not advanced or sophisticated because the fraud is also getting more intelligent, right? So that's why we are presenting here a technique using computer vision and deep learning to engage this effective solution for the vision frauds. So the current research gap, what we are in the market, right? So lack of robust visual fraud detection, as I said. There are technique currently OCR for the check detection and also for the CNN model for AI, only CNN based. But those are not like more than 90% accuracy. So we are trying to achieve as much as accuracy in the fraud detection on visually. So the current model, as I said, is on mostly on the data driven. We want to focus on this project. We want to focus on the visual artifacts. So I also want to use integrated the computer vision. CV is the computer vision here for the financial system.
So financial system as a workflow from start of the payment processing to the end of payment processing. We want to integrate the computer vision in that current workflow. So the objective is, right, so design a complete CV-based fraud detection pattern, which will fit into the current financial workflow. We don't want to have like new additional workflow, fit in the current workflow. Evaluate the current model, right? We have the existing models, not only stick to the one particular model. We want to have the CNN, which is convolutional neural network for the AI, and the GANs, which are for the generalized appraisal network, which are basically generative and discriminative network for the AI model generally currently used. And assess the performance, all these different models based on the different data sets, right? Those are for the checks, heat maps, and also for we get the IDs. So those are different data sets we want to evaluate. So methodology, what we use is we collected the data. So one thing I forgot to mention, this project is funded by one of the bank, PNC Bank. I worked for the PNC Bank from last like 15, 18 years. So this is we are doing this paper in collaboration with the PNC Bank. So we got the data, which is obviously not client data, mock data. The mask data, client information is not there. We got that data. Once we got that particular data set from the bank and also public domain, we use that data along with, we generated the data based on out of that as extension of the data. So those are the data set what we use for this practice. Then once we receive data, we pre-process the data. So images and everything, we have to resize and normalize those images to fit to the application. So that was the pre-process has been done. And then we feed this data to our model architecture, which is attention-based, CNN and GNN-based. We feed those images to this computer vision models. And what are the data we receive? We use the 70, 15, 15 model. 17 we use to train our model as a data. 15 is for the validation, and the 15% is for the testing. That's why we normalize those data and use for this particular technique. So once we receive this data, we model them, we test them with the different model. As I said, we don't want to stuck with the one particular model. We develop based on the baseline CNN, attention CNN, ResNet 50, and so GAN CAN, which is combination of the last one is CNN, is the convolutional neural network, and the GAN, gradual appraisal network. Yeah, those are the combination. So we evaluated all this based on the different metrics like accuracy, what is the precision, recall, and the F1 score for all the model. And after this, what we found out that CNN and the GNN based architecture is the most effective one. I don't have the table here, but only CNN based was baseline CNN was 89% was the accuracy. Attention CNN is the 91. ResNet 50 was 93, and the GN and CNN basis was the 94.6% accuracy to catch the anomalies in the visual frauds. Right? Yeah, these were the findings I was talking about. The GN-based argument training improved detection of the edge case scenario. So CNN, which is AI-based technique, gives us the 89%, but there are certain edge cases we cannot catch with the different fraud. And if you do a, like say, do a check forgery, or if you do the bank notes, if you're the fake ID document, we have the identity protection, right? We have the identity loss. So the KYC document. So those are the things which are visually is not 100% or more than 90% captured by CNN. So GNN was, we used to capture 94.5%. Yeah, those are all CV based findings what we have. Then implication, right? So how bank can use it? So bank can use this CNN network like currently what the network we develop in the current workflow. So when we send a payment, let's say I send payment to someone else, to the bank, it's not straight away go. It has to follow the complete cycle. So first payment goes to the AML, anti-money laundering, first goes to the sanction check, then the account lookup just to make sure account is present. You do a lot of different checks, date and amount. And also the payment you're sending to, that is valid bank, valid customer, all those different things. So we want to fit our model, we want to make a modular based existing platform. So we want to extend it. Currently what bank has the current tabular based validation, we want to add extension to that. So that is what the implication bank can use it. with this, we went to achieve, reducing in the false positive and false negative. False positive is the system catches something positive, but is really not really fraud. False negative is different thing, which is system does not capture certain thing, which is really it has to capture. This is where the different bank they get a lot of financial fines by the regulators because they don't catch the frauds. So this is what the system was able to reduce the false positive and false negative. And again, it was scalable to the other domains as well. It's not with the financial, because once we develop a system which will catch the visual anomalies with the checks and anything, this is just like picture, you catch the duplicate picture, the fake picture. You can use the capture in the healthcare network for the X-ray and the scans if they're duplicate, somebody submitting it. Also for insurance, somebody sending the fake ID, fake presentation, documentation. Also for the retail, there are a lot of counterfeit duplicate product. Retail industry can use it in the future. So that is the implication. Yeah, that's it. Yeah, that's it. Thank you guys. That's the presentation. Yeah, so sure.
I have one question. So other than fraud check detection, right? Do you have, could you name any other useful for financial banks to use this technique?
Oh yeah, so currently, okay, so I'll tell you, right? So this is what the PNC bank asks us. So currently what we are doing, right? So you go to the bank, sometimes you do the thumb and everything, right? So that is one use case. Existing use case, you can do your fingerprints, right? You can compare that one. But now industry is going. Now if you see the most of the airport, if you go, your the picture taken, your the image processing. The banks are moving to that as well. They don't want to have like touch base anything. Don't, if you walk in as a customer, don't put your fingerprint or anything. Just walk in, they will scan you who you are. So that is something the image-based bank is going to. That is something next use case we have.
Instead of blindly following or
Yeah,
believing on our ID.
Correct. Yeah. Yeah.
One question
Sure.
I had was in terms of like existing methodology, what have you compared, like how much of a difference this makes?
Sure. Yeah. So as I said, right, this is not replacement of the existing fraud, which is the database, right? So data, which is like, let's say you have the tabular data, who's spending, you're sending duplicate payment to same customer again. It is not for that, it is for checks. Currently, we have OCR system, which catches the duplicate thing. That accuracy is 78%. The current CNN model, which is the AI based, currently bank has, which is 89%, many bank user. We are proposing CNN plus GAN adaptive network, which is 94%. That's what it is. Yeah. Any question? Sure.
So you mentioned the project is getting intelligent.
Yes.
So what are you planning? How are you planning to keep up?
Yeah. So as I said, like there are two networks we are using ANet. One is CNN, which is everybody know convention vision based, right? And next is GAN. GAN is like a generative appraisal network. It has two submodels, right? One is generative and discriminative. It itself act as I'm making a fraud, right? So how does it work? Generative, if you submit something to it, the internal model generates fraud image of itself. Now we have discriminator, which will capture it within itself, right? So they work compete with each other. Discriminator has to catch what generator has generated, and that's the system will capture it. That's how we make it for this. Yeah. Thank you.
Thank you, sir, for your presentation. Next, we have Gurpreet Singh Sidhu, and his paper title is Risk Management in Cryptocurrencies, a Portfolio Perspective. The paper ID is 228.
No problem.
I can check.
Good morning, everyone. So I'm presenting a paper on the risk management in cryptocurrencies, a portfolio perspective. So what's the objective of this paper? So the objective of the paper is analyzing the role of cryptocurrencies in enhancing the portfolio diversification. So the comparison, evaluating risk returns profiles of the major cryptocurrencies like BTC, ETH, and BNB. So against traditional assets like equity and bonds. The key findings. The cryptocurrencies offer higher expected returns but carry sustainably greater volatile trial risks. The correlation between crypto and traditional assets remained really low, supporting diversification benefits, yet correlation spiked during downturns. That's one of the major issues with the cryptocurrencies. So coming to the risk mitigation strategies, apply value at risk, VAR, and conditional VAR for trial risk assessment. Use crypto future options and allocate portion of stablecoins and downturn buffers. Cap crypto exposure to 5 to 10% of the portfolio to balance the return and risk tolerance. So, and the regulatory, as the cryptocurrency, everybody knows it's a new thing in the investment market. So regulatory is not really good on it. So cryptocurrency market are highly reactive to regulatory changes, adaptive risk frameworks, and continuous correlation and moderating the essential. The policymakers should clarify tax, custody, and investor protection rules to foster institutional adoption. Moving forward, finding and discussions. As you can see in the table 1, the correlation matrix in table 1 highlights the cryptocurrencies, particularly Bitcoin and Ethereum, exhibits strong positive correlation between each other, but weak correlation with traditional assets like equities, bonds, gold. Bitcoin shows a low correlation with the S&P, indicating the limited diversification benefits. Treasury bonds, gold remain largely uncorrelated with cryptocurrencies, enforcing the role of risk hedging assets. The data suggests that while adding cryptocurrencies to a portfolio, many increase volatility. It can also provide a diversification advantage due to their relatively weak ties to traditional markets. Moving forward, cryptocurrency market crashes, and as shown in figure 1 and table 3, resulting in severe downturn, with a Bitcoin experiencing losses up to 50% during COVID-19. Like during COVID-19 in 2020, the portfolio, while 10% crypto allocation, saw a downturn up to 20-25%, showing that diversification reduces the losses but not eliminate the risk. Recovery time vary, managing from 6 months in COVID-19 and 10 months in FTX bankruptcy. This highlights that needs to long-term investments, strategies, and proper risk management to withdraw market downturn and the market regulatory changes, emphasizing on importance of monitoring legal development and risk management. Moving forward, stress testing, as shown in table 3 and fig 2, indicates the crypto inclusive portfolios suffer heavier losses. Traditional portfolio during the crisis. The COVID-19 crash led up to 12% loss in traditional portfolios compared to 18.5 for 10% crypto allocated and 30% for 20% allocation. Similarly, the FTX collapse, interest rate hikes resulted in more severe losses for portfolios for higher crypto exposures, highlighting the necessity of effective risk management strategies when investing in digital assets. Coming to the conclusion, So diversification versus the risk trade-off. Cryptocurrencies, while offering diversification benefits through low correlation and traditional assets, introducing significant higher volatility and trial risks. Optimal allocation, limiting crypto exposure to approximately 5 to 10% overall portfolio, balance enhance the return on the controlled risk. Risk management tools, implementing the advanced metrics like VAR, CVAR, hedging strategies, and stablecoin buffers effectively mitigates the downturn. Dynamic monitoring, continuous correlation, analyzing, and adaptive framework are crucial given the market regulatory policy implementations. Clear and consistent regular enforces responsible to institution adoption and enhance market stability. The future research. DeFi tokens study how decentralized finance assets perform as diversified as their unique risks. CBDCs evaluation central bank digital currencies and emerging portfolio and their interaction with crypto markets. Stablecoins. Future analyze the stablecoin roles in portfolio risk reduction and liquidity provision. Advanced modeling. You can use advanced modeling to explore AI ML methods that stress scenarios tailored to crypto non-stationary behaviors. So that would be all. Thank you guys. Any questions though?
We know that everybody know that risk is very high in the crypto right when compared to the traditional stocks.
Yeah.
So, what is the key thing you were actually?
So actually, as everyone knows, crypto is a new thing. Everybody's adopting to it. Government is adapting to it. Like different, like US has, and with the new Trump administration, they have more adapted to the cryptocurrencies. I think so. We cannot go 100% into it. We should start with like 5 to 10% of the portfolio that we can deal, that we can mitigate our risk. As we also know that the crypto rates, the profits are really good at it. That's why we can start with 5 to 10%. And while the government get more regularities on it, and we can increase it on day-by-day basis.
The trust basis, like the platform trust basis, like if you buy the actual public traded company stock versus buying some digital currency, right? Is there any trust issues buying one versus other? Like, can we compare those?
Of course, there, as you can say, like the government regularities in the traditional method, like bonds and everything, has government regularities. But this doesn't have a government regularity till the date. That is a major issue that it needs. But if we say on this risk base, it's more secure because it's everybody can see it and nobody controls it. The market, no particular market controls everything. That's also it's a decentralized that helps us to make more consistent in future.
Do you have a sense of when this can become commonplace and what is your study of projections?
So to be honest, like many government is implementing these. Like I told you, the Trump administration is implementing it. The Nepal government is mining Bitcoins from a long time. So that is like when the governments are adapting it, it will probably get adapted by people by it slowly. But it's projection like till 2030, many other portfolios will hold like 10 to 20% of the cryptocurrencies. So, thank you.
Thank you, Gurpreet, for presenting the paper. Next, we have with us Mr. Ramakrishna Ramadugu. He is going to present his paper on a formalized approach to secure and scalable smart contracts in decentralized finance. We welcome you, sir. Yes, over to you, sir, please.
Thank you, everyone. Good morning, everyone. My name is Ramakrishna Ramadhu. I represent for the Finance for Technologies. I'm into the fintech world. So first of all, thank you very much for the MIT University and all the who are actually organizing this one. And thank you very much for giving this opportunity for me. Today, I'm going to discuss about the formalized approach to the secure and scalable smart contracts in the decentralized finance. Okay, this is very interesting topic actually. Every day we are indirectly are using all these money movements and everything, and we don't know what exactly is happening in the behind. So we have the centralized, the decentralized. We are talking the different kind of the buzzwords and all. So today I'm going to explain actually how the decentralized finance actually we can do the more efficient by using this formalized approach. That's our today's topic. So let's start with the introduction actually. So in this introduction, we are going to check what is the need for the secure and scalable smart contracts in the decentralized financial systems, and what are the challenges actually traditional versus digital language verifications versus actually the execution of the gas cost, and what is the performance and all, and what exactly the approach we have taken. That is a Plutus code. It is a formally typed language for the transaction validations. So before begin with the next steps, actually, just I'm going to give you small examples. Like everyday real time we are doing in US, suppose the Zelle payment we are doing. So that has to finish it within 30 seconds with SLA for others, but usually it will be 15 to 20 seconds or 30 seconds, something like that. But the back end, the mechanism of the processing system will give only the 9 to 12 seconds at the time. But that nobody knows actually. But in that 9 seconds, what exactly it has to do? It has to do the fraud check, compliance check, balance check, and all these kind of information. The external systems, it has to send a request and get back the information, and it has to validate, and it has to credit in this one. So of course in US actually it's after 2015 it is already a lot and it's Zelle and all. But if, for example, if you take India in 2010 we already started the INTSCS system, and even Mexican peso started in 2008 or 2009 or something, in that area. Even India started CBDCs, just now Gurpreet someone mentioned, right? So the central bank digital currencies also introduced in last after COVID and in 2022 and 2023 experimentally already started. It's working very well. That means everyone is right now moving towards to the blockchain technology side as well as with the traditional, but still blockchain is under the control. This central bank under the central bank. That's called the CBDC around. But okay, fine. But definitely we need to know again here also the performances. So for these challenges, we're going to achieve to the protest code that is a lambda-based calculus calculations. That's what actually our research is. I'm going to explain more on that. Okay. So again, already partially explained the gaps. What exactly the gaps in this one is right now is a limited support for the only the formal verification in the smart contract design one, and a high gas fees because the one transaction cost. One transaction means it's not only the money moving transaction actually, whatever the transaction is good is started and you said so go to the external system and get back to the response and everything. That is taking a lot of the gas fees. We'll calculate into the gas fees those. But those sometimes actually is going on the loops. If it is a decentralized finance, it's going on the loops and it's costing a lot on that. So those kind of things actually we need to cut. So next is lack of the interoperability. So in the blockchain systems, we have you may have heard of the Ripple, Cardano, Ethereum. It's a different kind of mechanisms are there, but interoperability is not there. Again, we have to start from scratch. If you're adapting the Ethereum again, you need to start from scratch. We cannot able to use everything. So those kind of things actually we considered and we started our research on this one. So in the main objective is here to design very secure, scalable smart contract framework by using the Protoscore, the lambda calculus system, the formula based system, and utilizing the advanced type systems in the formula verifications also. While before building or before deploying also, we can insert these formulas and we can check the performance and everything. Those kind of utilizations we can check, and how the chain is going to be improve on the reduction of the execution risks, as well as going to the infinity loops and getting back the values. And there actually we can save a lot of the gas or performance time, everything actually we can include over there. So next methodology we can discuss here. So that is I already explained, right? So the Plutus score lambda based it's actually recursive types of the higher order functions actually we used. So incorporation of the static type of checking and bounded execution models.
So instead of going to the infinity loops, actually, where we can cut actually what exactly, I mean, at what point of time when to take the decisions. That's what actually we researched. And a formula actually via lambda calculus service for the, it's a predictable education, I mean, execution actually. That's the reason actually we have approached this lambda based calculations. This is in short for the methodology. And let's go to the analysis. Analysis actually the grammar was actually the detection rules of the protest code is given. Right now already we have the well-defined grammar is available in the protest code, but actually how that we can implement to the detection to the gas projects and everything. So next is we created some of the built-in functions. Actually, we use the built-in functions in the transactions, and we used into the transaction behavior, and we tested actually how much actually time or how much gas we can save on that one. So example demonstrations including a Boolean value signed, it's a normal signatures. So the like again I'm going back to our regular example like the Zelle payments. If you do it actually, so what we are thinking is we can insert in the payment online, but in the back end actually it will do the digital certification validations. So those kind of things already taken care by the system in the traditional. In the same way in the decentralized financial, also the blockchain technology also we can use it actually. So those kind of things actually we need to test it, because in order to obtain to the many banks or any kind of the financial institution systems, definitely we should have all these kind of compliances. Then only actually they will be able to use this. So what's our initial findings in this complete analysis? So actually we have been the verification of the DOS, the denial of services risk actually is the mitigates actually maximum of the DOS attacks over there. And next is the type of system reduce the runtime errors and the gas inefficiencies. Because of that, actually we are not going to the infinity loops, or we are cutting exactly where exactly we need to get the responses and all. So that time actually we saw a lot of differences over there. And again, the model supports actually the transactions validations with the UTXO. That's nothing but actually enhanced unused the transaction times, because sometimes actually one transaction is suppose using the A to Z all the interfaces, but some of the transaction will use only A to B and is completed the transaction. So still there is some 24 interfaces still we are left with us. Those actually we can assign back to the some other system which is taking a lot of time or which is taking a lot of performance and all. So those kind of analysis have been completed. So what are the implications actually? So again, I just explained, right? So we need to have this kind of a digital certifications, everything, right? So by including all, so definitely is going to be the trust into the digital decentralized finance system. Still, actually, if you want to use it actually with the banking system, you're ready to use, but most of the people are still hesitated to use the blockchain systems and all, because even though it's a very robust and everything, but still most of the people does not aware, and still it has maybe any scams. It's a lot of things as it consist of. That's the reason we want to build a trust on the decentralized finance applications to these verified smart contracts and everything. So potential for the enterprise adoption for the formalized blockchain technology in the text. So most of the technologies right now they're using the cryptocurrencies and all, including CBDCs right now. Though it is a central bank under, but still is going to be use the mechanism is completely to the blockchain technology blockchain technology mechanisms only. So this is one of the things. So improve the scalability and the security standards for the decentralized platforms. So when we come to the decentralized platforms, so nobody is actually is authorized for that. No central bank is authorized for that. So for that we need to make it a trust. So that's what actually the implications we studied. I think that okay. Thank you. Yeah. Any questions?
It's maybe planned question. So you mentioned about the transactions and what all the enterprise that in usual example we give, right? So how the gas, you mentioned the gas inefficiencies and how the gas inefficiencies and smart contracts and the transactions related. I'm trying to.
Sure, definitely. So what happens is actually the smart contracts right now is not actually the formalized, so that if somebody is actually inside of one of the smart contracts over there, might be that the loop, that means when we come to the verification of the validation purpose of that smart contract, actually sometimes the loop is not completed, still actually running, and it's giving the values. I mean, instead of giving the complete data one time back to the response, or might be searching for somewhere else and giving back and going back to someone and getting back and giving back to the phone. So that is taking a lot of time, and they're wasting time over there. So instead of that, what the smart contract is supposed to do is first, what are the what are the interfaces it has to go back? First go back and get it the information, everything, put it together and send it back to the answer.
Real-time example for that contract and gas you talk about.
Yeah, gas in the sense actually, okay, gas is the blockchain
Gas
language.
price.
Yeah, not actually normal gas price. The gas we'll use in the blockchain technology is for the transaction time, how
Oh, I
much is
see.
take.
I got it.
Okay, that is a gas actually.
I see.
So,
Okay.
yeah, that's
Now I understand. Now
okay.
That's all.
I wanted to understand, like you mentioned that if there is something that is looping,
Mhm.
you basically this mechanism finds what other transactions are waiting. Is that kind of like, you know, a round robin system, or how is that?
Yeah, it's okay. Again, there are two things here involved here. One is right now, when again I'll go back to the same example of the Zelle payments, right? Zelle payments is actually the synchronous. Synchronous in the sense, once you ensure the payment, you have to get the response back, then it will be closed. Otherwise, your payment is dying and your payment is cancelled or something like that. So some of them is asynchronous. Okay. So mostly right now, because of the time sensitiveness, everyone is going with the synchronous system. So once we started the synchronous system, so just now I gave the examples of the interfaces, right? So it will stop actually. It's a round robin, but in order to complete this round robin also, you have the limitation of the 30 seconds of time. Just I'm giving the one of the examples of the 30 seconds. So in the 30 seconds of the time, how much efficiently we can go back to those interfaces and get back the responses and bring back to the system. That's the main goal. Any other questions? Thank you very much. Thanks a lot.
Thank you so much, sir, for a wonderful presentation on a formalized approach to secure and scalable smart contracts in decentralized finance. Thank you so much. We have with us How to see the slides?
Okay.
Yes, please. It's not moving.
Oh.
Observe, it's not moving. It's not moving when I'm moving from here. You only think this. You have to this one. So that's why I'm asking them. Yeah, that's it. Now you have to open my camera and everything. So good morning, everyone. Sorry, good afternoon. So we are going to present one paper on prediction of mental health issues in textual dataset using deep learning. I, along with my co-author Ronak Singh Kharbanda. Ronak, are you here?
Yes, ma'am. Good afternoon. I'm audible.
Okay. So this work has been done by a set of students, Ronak and Tanmay, who are doing their major project as a part of their BTech degree. So they have done paper on prediction of mental health issues in textual datasets using deep learning. Mental health conditions frequently remain undiagnosed or untreated due to limited resources and delayed intervention. With the growing prevalence of individuals sharing personal experiences on digital platforms, this study is going to leverage natural language processing and deep learning techniques to enable early detection of such conditions. Certain existing model that has been used in previous works. First one was HNN, that is hierarchical attention network, and convolutional neural network, but they both often struggle to fully capture deep emotional context, which is vital in analyzing the mental health conditions. Many of them, both of them also act as a black box, offering little interpretability, a serious concern when dealing with issues of human well-being. Most previous research simplifies the problem into binary classification. However, as we all know that real-world mental health scenarios are inherently more complex. Additionally, mental health datasets frequently suffer from class imbalance, which can skew model performance. Finally, attention mechanisms that could enhance the focus and transparency are often less explored or insufficiently leveraged in the context of mental health applications. So these gaps have shaped the core direction of our research. Our objectives focused on overcoming the current gaps, particularly interpretability, class imbalance, and limited classification scope. So, taking inspiration from this, we aim to build a scalable, transparent, and accurate model that can support early mental health intervention. Our dataset comprised user-generated text entries that has been categorized into 5 distinct mental health conditions. A major challenge encountered was class imbalance. For instance, the depression category contained over 15,000 entries, whereas personality disorder had just over 1,000. To address this, we simply use the concept of synthetic minority oversampling technique to generate the synthetic sample for unrepresented classes. Additionally, we perform undersampling by capping the dominant classes at 30,000 entries each. Duplicate entries were also removed to prevent skewed learning and enhance the overall data quality. Due to the time and privacy constraints, additional data was not possible. That's why SMORT helps generalize minority patterns, and it is widely accepted in text classification when the real data is sparse. We began with CNNs for pattern detection, but found them limited in understanding the long-term context. Then we have used the concept of RNNs, recurrent neural networks, and they improved the sequential processing, but couldn't handle the long inputs effectively. LSTM solved this with the memory gates, and BiLSTM took it further by processing input in both the directions. Finally, we explored the combinations like artificial neural network plus LSTM, and then we have tried for RNN plus LSTM, which merged deep feature extraction with the temporal understanding, leading to better accuracy and emotion detection in text. Understanding each model limitations helped us benchmark improvements step by step and justify that why we have used the concept of BioLSTM and why it is superior because of its superior performance and context-based learning. Accuracy, precision, recall, F1 score, and training convergence stability has been checked, and they all has been used consistently across all the architectures. ANN captures high-level abstract features from the textual embeddings, while LSTM captures temporal relationships together. So both of them significantly enhance the prediction capabilities. So this is the final architecture that we have come up with. And now I want Ronak to explain the final model architecture for ANN plus by LSTM. And we have used hard attention in this. Yes, Ronak, over to you, please.
Thank you, ma'am. That was a wonderful explanation of our project. And I would be now going towards the architecture and the practical portion of this project. So as ma'am told you that we tested different models that was from CNN to the LSTMs to RNNs. And based on that, we came up to a conclusion that the best way going forward is to test with hybrid models. That is in the combination of BioLSTM plus ANN because of their nature of BioLSTM in this case, forward and backward contextual dependencies. And why did we use hard attention mechanism with it? It basically because it focuses on the most relevant words or the phrases that were used in our input. In this case, the data set that we have used, and it improves the interpretability and the accuracy. Going forward, we have also, after getting accurate and substantially good results, we add additional enhancements by the use of glove embeddings and circular learning rate. Now, if to understand what a glove embeddings and circular learning rate comes into play, glove embeddings basically is a type of tool which is used here to capture semantic rich word vectors. It's kind of vector we use to basically capture the semantic text beyond the local usage. And it reduces the sparsity and improves contextual understanding of the text. And we're talking about not a small text here. We're talking about a huge lump sum of text exceeding about 30,000 samples. So it helps us to be more direct and able to remove the overfitting that we might face or we faced earlier in our project. And we also used the circular learning rate. This is a cyclical adjustment of learning rate between predefined bounds. That means we have defined the bounds between a data set, and it helps escape us the local minima and improves convergence stability. Other than that, when we were testing and we were working on different models, experimenting with them, we used different optimizers in that, in which, such as the most used one, the Adam, RMS prop, AdaGrad, in which we found the most the model, the optimizer which worked the best and showed the highest accuracy, the test accuracy, along with the other evaluation parametrics, was the Adam optimizer. It actually showed faster convergence and it was very consistent in the gradients. Finally, this was the evaluation parametrics, which we calculated after a thorough research going through testing of models, hybrid models, integration with attention mechanisms, and different optimizers. So the final accuracy that we found was 92.05%, along with the precision, recall, and F1 score ranging from 92 to 93%. This was the strategy that we used here was more of an 80-20 in the train test split. Based on the literature review we did from the past studies done in this field particularly, this was the best evaluation parametrics that we got, considering that we have not used a transformer model such as a transformer model in this case. So that's why we have found the best accuracy and the evaluation parametrics. Now, going forward, this was what I was referring to earlier on, that based on other research papers or other research that have taken place in with the scientists or the researchers have experimented deep learning models on textual data sets. These were the evaluation metrics which we found, and our proposed model substantially performed very well, considering that the model was built from scratch and no transform models such as a BERT was used in this. The benchmark models, which ma'am earlier on the presentation explained, such as the hierarchical attention networks or the GANs, they also were not able to provide such a substantial accuracy, and in terms of the research that we have done. So the ANN plus BiLSTM model with the integration of heart attention mechanism proved to be outperforming both traditional and advanced models in accuracy, interpretability, and generalization. Finally, what is the implications and the future scope? Well, more or less, our current models demonstrate strong performance, and they have showed us promising avenues for future exploration. As I told you, with this research, we can also move towards using the same research, the same parametrics in the transformer-based models to understand the context and the generalization. And we can explore multimodal deep learning for combining text, because remember, these researches didn't only just what they are pertaining to textual data set. The research was also based upon the audio and the video data sets, which means that there's a lot of scope to expand in this entire field of prediction of mental health illness, which is in today's time the need of the hour to treat these illnesses and detect them at the earliest. Real world deployments, such as building an open source diagnostic tool for researchers and mental health professionals, and enabling user friendly interfaces with real time predictions. What we have to ensure is that these models that we're building are complying and are in the not really bounding with the laws, such as the HIPAA or the GDPR laws, because these are the laws that govern the governing bodies that safeguards the data, the health data of the citizens of different countries, to be more precise in that. So we have to, of course, go forward with precision, but also with caution. And thank you so much for your time and attention. It was an honor to present this PPT along with Garima ma'am, Dr. Garima Agarwal, and my fellow teammate, Tanmay Baluni. We welcome your questions.
Thank you so much. Thank you, Ronak.
Thank you, ma'am.
I had was that huge gap between other models and the proposed model. Was there any substantial reason that you guys found about why that all the models were like 75, 76%?
So Ronak, can you answer this question of ma'am, that how you have selected this model? Because other models are basically giving a less accuracy of around 70%. So what keeps this thing in your mind, that how you have got this idea that you have to make a combination of these to improve the accuracy?
Well, it wasn't completely our idea. Our faculty, in this case, the AI lab of Amity, was very helpful in this case. What we were working on was we were first testing these models in an individual capacity. What I mean to say is we were not testing them in combinations. So, but as we're told, we were facing a couple of challenges. First of all, we were not able to find, even after we tried to do the model tuning of the data sets, the fine tuning of the data sets, but that wasn't resulting in higher accuracies, or even because based on the research we did as well of other researchers, these accuracy standards were way low. So that prompted us, our faculty and us, it prompted us to test these models in a hybrid capacity, in a combination of them. And as we know, these models in their individual capacity, such as an LSTM or a BiLSTM, they are, though they are complex models, but they are the ones which are used when we are dealing with the textual data sets because of the nature of these models. So the idea was just step by step. It wasn't that we jumped straight away to testing the hybrid models. We went from testing them in individual capacity. And once we were doing well with them in the hybrid capacity, we just prompted, okay, there's not an issue of overfitting or underfitting going on. We should test them with the attention mechanisms. So that's how we did. Mind you, in this case, the data set we are dealing with was a combination of 8 to 9 different sources and over 50,000 samples. So we also had to balance the data set as well in order to have a uniform uniform evaluation parametrics and to avoid overfitting. So it was step by step. We tested each and every models, and that prompted us to take necessary steps in order to come to a conclusion in this research. I hope that answers your question.
Hope you got your answer. So they firstly started with CNN, But then subsequently they moved towards the RNN because this is a long 1 year project with them. So in the first 7 semester, they have to do the literature review. So in the literature review part, they have done the part of CNN. Firstly, they identify with the CNN, but we all know that we have to struggle for long range concept contextual understanding, and CNN will not be useful for that. Then they move towards RNN, then tried for LSTMs, and but by LSTMs reads the data both in forward as well as backward reasoning. So they preferred by LSTM, and then that also help in moving towards more comprehensive semantic context, and it remembers long-term dependencies also, and that is required for getting for predicting that what is the mental health data set, because it is we are taking text as a data set to check whether to predict basically mental health disorders. So that was good at sequence classification, and then we have tried for ANN plus BiLSTM or RNN plus LSTM. So this way we have progressed, and finally we got good results from this. Thank you. Thank you, Ronak.
Thank you, ma'am. It was a great presentation. Could we leave?
With this, we come to the close of the first technical session for today. I extend heartfelt thanks to all the presenters, and a special thanks to our session chairs, reviewers, and attendees for your engagement and thoughtful, provoking questions. Let's take this carry forward the spirit of collaboration as we move into the next session of the day. Thank you so much, and we are going to have a little break here. So we are going to resume this session at 1 with our next set of presentations. And until then, you please feel free to network and connect with the fellow delegates. And you can also connect with the session chairs, because they will help you out in getting good internships or giving good research ideas. So you please also guide our students that how they can start their research, because all they are BTech students as well as BBA students. So they can, and in India, we are having research as a primary component in their all the degrees. So they have to do their major projects, and they are third year students. When they are going back to India, they are going to start their research. Again, they are going to take specific set of topics. So please feel free to take guidance from them that how you can start your research work in the next coming year, and that will beneficially help you. Thank you so much. Thank you, Vinita ma'am. Thank you, Pranessa. Pranessa, you want to say something?
I mean, I listened to all the papers and they were well presented and they are good, interesting ideas. So probably they can work further on those topics and develop into full-fledged papers, not only conference proceedings. All the best to all the presenters, and a big thank to the 2 session chairs who are chairing the session now. And
Thank you so much, sir. Thank you. So we will start this next session at 1. And also we want to present our certificates to our session chairs. So Akriti, please. Yeah. Just give me a minute. Pranay sir, would you be able to please share the ICTM poster?
Yes, give me a minute. I'll
Yeah,
just.
please. Yeah, that's fine. लिखना पड़ेगा ना? Oh, it's,
I just
sorry,
realized.
sorry. अभी कुछ नहीं है, ये बहुत सारे
So just realized.
Oh, not issue, not issue. आपको ये अभी मैं आपको ये बता from your organization.
Dr. Garima, I sent you on WhatsApp, or do you want me to post it on the screen?
Thank you so much. Pranay sir, we are going to start our next session at 1 after 20 minutes. So shall we close this session? Mobin sir?
Okay,
Mobin sir?
we can, yeah. What do you suggest?
We will
Should
start the
close
next
it? I can
session
ask
at 1,
Mobin.
sir. So you can close this session for a while.
Okay, let's close it. Let's close it.
Thank you.
IT host, I think it is Puneet. Puneet, IT host. I'll telephone and then ask them to close. हेलो पुनीत जी, अभी आप यूएस वाला सेशन देख रहे हैं ना? ये लिंक वन को अभी बंद कर दीजिए, फिर 1 बजे मैंने वहां के टाइम के हिसाब से 20 मिनट बाद फिर स्टार्ट करेंगे। हाँ जी, जिसमें मैं हूँ। नहीं नहीं, अच्छा अच्छा अच्छा, वो कौन है? मोबिन कर रहा है क्या वो? अच्छा ठीक है। हाँ मोबिन, ये सेशन को जिसमें मैं दिख रहा हूँ ना, इसको बंद कर दो, तो 20 मिनट बाद स्टार्ट करेंगे, ठीक है? नेक्स्ट सेशन। कल क्या किए थे? हाँ तो इसी को चला दो, ठीक है? अच्छा ठीक है।
So we welcome you back once again to all the guests who are present here and everybody who is joined from the Zoom link. We are starting the afternoon session, and our first presenter is Ms. Drishti. Her paper title is a correlation-driven framework for multivariate time series forecasting.
Great seeing people from India and here. Great seeing people from the world. For the session. Deep interactive, please ask questions.
Thank you for the introduction. Thank you, sir. Good afternoon. My name is Trishti Nani. I'm currently working with ACES as a data scientist, and I am here to present my research paper named A Correlation-Driven Framework for Multivariate Time Series Forecasting. This work primarily focuses on improving the time series forecasting and explicitly modeling the interdependencies across variables when it comes to multivariate time series as opposed to univariate. We know time series forecasting plays a critical role in areas when it comes to finance, climate science, especially with power systems. Traditional approaches often fall short when it comes to dealing with time series, especially in multivariate, because they don't model the interdependence between variables. We are either within univariate or with multivariate, the interdependence is not looked after, or the correlation structures are not fall short within these transformations. Going forward, our method targets point-wise time series forecasting, meaning we aim to predict the next value in our time series using our previous values. So for multivariate time series, we have multiple series evolving together, thus capturing the interaction between these series. We break the process into 3 phases. One being the transformation of the source space into a metric space. 2 being predicting the distance of time series into a distance matrix. Then secondly, predicting the distance. And thirdly, reconstructing this back into the source space. Our entire research is focused on the interdependency of these variables, thus focusing on the gaps of the multivariate or gaps of the other research of multivariate time series forecasting. That brings us to the gaps of existing approaches. Traditional methods like LSTM being our long short-term memory and singular spectrum analysis, SSA, typically target univariate series. If we were to make them multivariate, we just combine them together. Such methods would, as I said, not account for the interdependencies between these various series, thus missing crucial relationships between this information. If we miss on the crucial relationships, we are actually missing out on prediction accuracy. So that is one gap. The other side of it is transformer-based models. Recent advancements we've seen in transformer-based models have come from our natural language-based processing tasks, transformer model being an example. That does look at some of the interdependencies, but it does not directly model the distance function. So both of these gaps is what we're trying to reach within this current approach. And yeah, that is our research objective. Getting us to our next slide. As said, our research objectives are one, to improve our multivariate forecasting, thus enhancing the prediction accuracy for this very complex time series data. Secondly, would be to leverage the correlation matrices, thus actually utilizing pairwise relationships between all of these variables. Third would be to develop this reconstruction algorithm to actually create methods and accurate source space reconstruction. And fourth would be to actually validate this through experimentation and test it through synthetic and real world data sets. Now, we do want to address the limitations of the existing approach by developing this framework that would address relationships between multiple time series data sets by transforming this data into a metric space that leverages correlation matrices. The goal is to capture complex dependencies, and the traditional methods do miss that, thus hoping to ultimately improve forecasting across various domains that we're targeting. Our methodologies is what we'll go over next. The core is to transform the source space into a metric space and go through doing that using our distance matrices. So we do that using our pairwise distances, using between our time series values, creating a structured representation that captures distances, that captures the relationships between the variables. Predict that pairwise distance matrix in our next step, using historical values, use SVD or singular value decomposition to reconstruct our source space, and then apply correlation-based algorithms to predict our next steps. Now, correlation-based algorithms, we've used specialized algorithms to make sure that it does call for or apply for both accurate and inaccurate data. So look for noisy data as well. And it can handle imperfections and real world noises. Our analysis of multiple solutions, or this would be one, we do have a single matrix limitation. So even though we have a single distance matrix, it would lead to multiple possible reconstructions of time series values. Or since we are doing pairwise correlation matrices, or pairwise correlation matrices would give us two solutions for each reconstruction. So we have dual solution theorem. SVD, this is an SVD-based solution. So singular value decomposition provides an efficient method to find both potential solutions, which is great for us. And a multiple matrix approach, using multiple matrices with different time windows helps identify which is the correct solution. Now, this research does demonstrate that a single distance matrix is insufficient. So the multiple matrices does help. For pairwise correlation matrices, exactly two possible solutions are there, which is great for us. And takes care of the closed form expressions to derive one or the other. Now, our experimental findings, with increasing K, which was our number of matrices, our results did get better. So even if we just look at this is k equal to 2 to k equal to 10, our results were better. Our MAE dropped from 0.316 to 0.116, from k equal to 2 to k equal to 10. However, we also do need to get into the factor that at some point of time, we cannot just keep increasing matrices. At some point of time, we have to get into the aspect of computational limits. So after running multiple rounds and epochs, we realized that k equal to 15 was the limit of computation. So that is the computational limit is where we have stopped. So that's our experimental finding. So that was the trade-off. Hence, we've just kept the analysis up to k equal to 10. And future directions. So theoretically, correlation or correlation matrices does yield to exactly two possible solutions for the time series reconstruction, providing closed form expressions. Thus providing an efficient way to compute both. Practically, it is a very, practically it can be applied in finance, climate modeling, power systems, everywhere where we do want to see dependencies between variables analyzed. However, we also would want to understand the time complexity between all of this, especially when it comes to area domains like finance, because we would not want this to take too long between systems. And especially if we're adding this as a part of some app, say like Robinhood, we would not want it to take too long. That would be something that we would want to work on. Future research direction would be to improve prediction accuracy of both the pairwise correlation matrices as well as the regression model, which was currently a very basic one that we use because it does not provide sufficient precision. Estimating error margin also when reconstruction time series model from correlation matrices, and exploring alternative pairwise distance matrices was also another future direction that we could look at. That's it. Thank you.
Just one quick question.
Yes. Yeah.
Are not attractive because there is computational sort of time.
Yes.
Are there ways to essentially combat that? Is it just increased computational power, or are there like algorithms that can have been looked into, like other algorithms that can as
So I think for this one, the computational, this was just 2 raised to k because we using 2 raised to the power k. I think we would have to, for practical applications, we'll have to first decrease our number of matrices that we're coming up with. So if it's, we can either decrease 2 or we can decrease k, right? It's there are 2 factors and that's about it. So we realized that when we increase k is when we're increasing our accuracy. So it accuracy is where we do this. So I think we would have to, like I said, instead of regression, we use a better model, or instead of we've only done prediction accuracy with the pairwise correlation, so we use a better distance prediction. So we've used basic prediction accuracy models only because I think my research was based only on trying and understanding the dependencies between the variables. But now that this is true, we can now put on using better models in both aspects of it and selecting better models to try and understand which model works better in giving better. But yeah, that's what you have.
Any other questions? There's no questions. Thank you so much.
Of course. Thank you.
Thank you, Ms. Drishti, for your presentation. Next, I would like to call Mr. Rahul Atore to present his paper titled Integrating IoT and AI for End-to-End Agricultural Intelligence Systems. Paper ID is 427. Over to you, sir.
Good afternoon, everyone. Chair, thank you for having me here. I'm excited to present my paper in collaboration. The study has been performed with Hemrita Bindu. She could not be here with the work commitment. Yeah. So today the agriculture is facing a lot of challenges regarding the quality food, the soil quality, and the population. So the aim is how to help farmer and also how to use the latest technologies to increase the food production, right? So we have the collaboration between our basic need, which is the food and farming, with the latest technology, AI and IoTs. So that's the really interesting thing we wanted to present here. So the topic name of the topic is right, integrating IoT and AI for end-to-end agriculture intelligence system. So and paper ID is 427. Yeah. So nowadays we all know, right? Agriculture faces a lot of challenges in terms of the production decrease. Many reasons. One is the climate, the soil condition, the weather, and also the poor labor, and also increased population. So both are going in different direction. So that's what this paper research is more about. So also the food, the demand of the food is increasing in the future based on the population. So we believe that based on the study, by 2050, 70% is more food is required as compared today, based on the population is growing, and which is challenging with the current the architecture, which is the farming, which is insufficient, and also the fragmented and the very traditional based. And so there are a lot of approaches, and the study has been done, which is AI based or IoT based. It's not that nobody is working or doing it. We are not claiming that. But most of the studies, they are doing either only AI or IoTs. IoT is nothing but sensor, or the things which are work on the internet, sensor and the, let's say drone, those are the multiple thing. And AI is like new techniques which work on the models like CNN, GAN. So those are things. We're trying to collaborate those two things, so that we get the most of the current technology for our basic need. So what are the research gap we found here, right? So existing solution, as I said, there are work has been done, but those are mostly on the specific sector, like AI is on the AI, IoTs and IoTs. So that's one thing. And also the limited scalability, the models they have, they work on the particular weather or particular crop. So if I have to do a farming, I have to go different place or different crop, I may have to adopt a different model. So we wanted to have like one unique kind of model, which is again, adaptive learning or fragmented learning, keep evolving themselves using the technology. That's one thing we wanted to do. And also, right, the current model is high dependency, and also they are running on the power, and also the using the network capacity lot. Like they are using let's say they're working on the cloud. So you need the connectivity. It's not that it's not possible, but if you go to the rural areas, the connectivity and power, right, there are the challenges, scarcity. So that's another one of the important thing in the research gap. And also, right, so what the research comes in, those are not mostly the AI we call is like external to the farmers, right? So the results are there. We need something which is easily explained to the farmer, all set of farmers, not only particular set of farmers. So that was one of the thing we have. So objective of our study is design a modular end-to-end IoT-based architecture. When I say AIoT, is combination of the word is AIoT is really AI plus IoTs. AI is artificial intelligence, IoT is Internet of Things. Those are the two things we wanted to combine. And again, we want to have modular end-to-end. We don't have one set. We don't want to generate one set. So the farmers, okay, you have to get completely one set. A modular base, something farmers want to replace for a crop basis on other basis, they can use the modular base, which is cost-effective one. And it's based on the system, which need to be real-time, based on the sensing base, right? And also the making automated decision with the help of farmers. So like farmer control, not help of farmer, the farmer control. Also, the system should detect the basic need for the farmer. One is the disease, right? So disease detection should be preactive, should be not reactive, should be preactive, right? So it should not be the case after the fact that disease is there, the farmer has to take an action. It's really, okay, something is on the way and coming in the line, so you have to take action, which is like reactive. And also, right, it should make a decision of its own and give, okay, the irrigation is needed based on the current condition, weather, soil moisture condition, the pH level. So it will help farmers. Okay, this is what you need to take an action. And also it helps with the forecasting as well based on the weather. So it will help farmers. So that's another thing actually. Yeah. And again, we need a system which is can be implemented at the rural areas, all kind of rural areas, and which is efficient for energy, not dependent on the network and the cloud. So that was main objective. So the methodology, right? There are 4 layers. One is the sensing layer in our case, communication layer, processing and application layer. The sensing layer is made from the IoTs, like sensors, which will sense the disease, pH condition of the soil, moisture, other. Processing layer, communication layer is it will pass the data, which is processing. Communication layer is like something which communicate between the sensing layer and the processing layer, which can be a 4Gs or internet thing, which called processing layer. And it will pass this data to the processing layer, which is made of the devices, Raspberry Pi, Jets, and Nano. Those are the devices, edge devices, which will sit on the local, not on the cloud, to sit on the local, which will use the data based on the sensor and take the decisions. So that was the processing layer. And all this based on, again, work on the AI models like CNN, decision tree, LSTM. CNN is for the disease detection. LSTM is for the yield prediction. Decision tree is for forecasting the irrigation, whether we need irrigation or not. That was the decision tree is. So next is analysis. So evaluation metric, what we did, right? So we compare edge devices versus the cloud devices. So again, as I said, there are cloud devices. Is Microsoft's Farm-based is one of the very good cloud devices using, but it's not sit on the local. Data goes to the cloud. It requires its own the communication, the network capacity. So we compare against that Farm-based, again the local edge-based devices. The matrix were the accuracies, latency, power consumption, F1 score, right? So what we found out that the interference reduced by 45%. Interference is nothing but the communication. So in the farm bit, you have to communicate to the central cloud layer. In the edge devices, obviously you don't have to communicate decisions in the local. It was reduced by 45%. The water saving is 23%. Obviously, you have the sensors which sense the data irrigation layer. So the use of the water is very good rather than the traditional way. It is by 23%. And the F1 score, which is for the disease detection. So CNN model, which you use for the disease detection, it was really a 91%, 0.91 the F1 score, which is detecting the disease. The finding here, the result, CNN-based disease detection was the 92.4% increase than the traditional ways where farmer goes and check, okay, something is coming up. He goes and asks for other people, okay, what's going on? Other than having a system which will tell, okay, this disease is coming. These are the preactive ways you can take, and this based on the image what they receive, it will compare with the data what they have in the data set. Okay, this is what they give the solution. Also is 92.4. Irrigation is also increased by 95.7% accuracy there, which is again Raspberry Pi. And LSTM is the crop prediction, which will give yield prediction. Okay, how much yield you can expect based on the traditional way. With this one is the increase by almost 18.4 and 19%. Right. And again, as I said, edge devices is very easy to deployment, low bandwidth, low power. I'll not say low power consumption, but low power bandwidth for sure. That was the use of the edge deployment, which is Raspberry Pi is what we used. So again, there are challenges. It's not something easy. It's very easy to say, okay, this is what you go and implement. It's not. There are deployment challenges. One is the sensor calibration. The IoT is what we use. The sensors, they could degrade over a period of time. So we need some system which is automated, again, not like manual, which will run on the software, calculate the calibration, right? And again, what is the drift going on, and do the calibration of that. The next is rural internet and power limitation. We are not saying that that if you use edge devices over the cloud, you don't need internet and power. You definitely need power to run the devices. And the rural internet, obviously, you need the Wi-Fi or the local phone network, at least to communicate data to the edge devices. Again, transferability across the region, the models what we have is not that the wheat production you are getting United States or the is same as the India or somewhere in Mexico is the same based on the weather condition. So the model what we use, it require the adaptability and need for external AI. So whatever the AI result present, the result should not be overhanging to the farmers. They should be very explainable to the farmers, and it should be have the mobile devices or some kind of devices which they can use and understand and take decisions. That's one. The implication, right? So again, real-time AOTs can be revolutionized in the farmers. Again, you can, as I say, the pre-active way, not the reactive way. Modular system. So farmers should have capability, or any user should have capability. They use the, they can replace the particular module. If they, let's say, there are certain sensor which act very good on certain condition or certain crop, they can only replace that particular module, not every complete set. Again, the future development will be there is for the XML AI. Currently we did not use that, but we need something, the XML AI, which will explain farmers, okay, what all this of data set, how to use it, how to take action on it, how to understand basically. And again, the farmers is we have to understand that farmer is for different region, not for like one region, different region in the globe. And again, we need drone fusion. A lot of farmers are currently using drone for sure for the spraying for the disease. Again, and so we can use that drone for the taking images on the different area and passing to the edge devices, and they can take decisions based on that. Blockchain is for the traceability and the trust of the farmers to trace their particular farm produce. Yeah, this is what we 100%. I'm not more than 7 minutes. Yeah. And this particular topic is close to my heart. I know I'm in US for a long period of time, but I'm basically a farmer, a traditional initiator farmer. So it's something we saw this problem over the period of time. Again, it's not something we can go away with this problem over a period of overnight or a year or two, but there's something need to happen for farmers. Yeah. Sure. Oh, that's great.
That's built back in India as well. One big limitation there is essentially the cost,
obviously,
especially for setting it up and then for farmers to essentially hire that. Have you compared essentially costs for sort of on-premise?
Yes, correct. So the Raspberry Pi, what we have, the edge device, is cost from $30 to.
Yeah, it's Raspberry Pi.
So super, $30 to like 150 based on the what model you have. That's something we analyze that one. And also the local cost, right? The cost really is for the initial setup that you needed, which is really a first level challenge. And the Raspberry Pi is the $30 to $150 based on the model what you choose. And again, you need on top of it the AI model on top of it, CNN or whatever you use. Yeah, we need to install that. Correct. Yeah.
Just in terms of computation, like I know it's like super responsive, but you're seeing very high accuracy rates. Were you able to like compare accuracy rates with like other modes as well? Like
yeah. We compare the Microsoft Farm Bit. Again, it's not that very big gap. Microsoft Farm Bit is like 89%, and the current what we use the technology is 94.5%, 5% gap. Yeah, that's the gap, 5%. But the major difference is the Farm Bit work on the cloud. So the data goes to the cloud and everything, not locally, and this is local and this is modular based. So if something sensor or some technology goes wrong, you can replace only that particular module, not complete whole set. That's another second thing. Sure.
So three sensors are needed for like what size of land in one sensor?
Yeah, so 1 acre, right? So we identify when we did the test, it obviously a closed circuit. The 1 acre we use the 7 sensor over it. Different places, 7 sensors. Again, it can go more and less, but 7 we thought is good amount of sensors, which is cost effective again. Yeah, sure. Thank you. Thank you.
Now I'd like to call upon Satish Kumar Nadella to present two of his papers, paper ID 116 and 117.
another one, the previous one, should give that a morning session. I think my other paper is in my morning session. Yeah. Good. I'm checking. Some reason I don't see that sharing. Yeah, hello everyone. My name is Satish Kumar Nagindla. I work for Amazon Web Services. I'm as a senior cloud infrastructure architect. Today, I would like to present a paper on generative AI for predictive safety for urban risk in smart cities. How we can leverage the generative AI in making our cities better. So I authored this paper with my co-author Harish Narne. So we both worked on this paper present, and today I would like to present this to you guys. So I would like to introduce the motivation behind this presentation. The paper is as we see that the urbanization is increasing every day, right? So we are facing challenges on various other departments like traffic management or crime, or including natural disasters, or too many things we are exposed to than before. So the idea behind this paper is to how we can leverage our advancements in our AI to make this the favor to our humans, right? So as of now, we are using some traditional systems, which is very reactive measures. Like what happened, let's say if you having too much traffic, and we are only realizing after some number of accidents happening in that junction, or then only we are reacting to okay, we are having too many accidents there, then change the lights or change the road, something like that. So this paper is going to give a predictive modeling stuff, like based on the real-time monitoring on the roads, or traffic, or for example, if I want to give in the traffic congestion, right? So if we can see that a real-time traffic congestions on the roads, so it can alert the cities saying that, hey, this junction is like too crowded from this time to this time, and so they can work on the constructing new roads or new lights, or they can work on that, so that we don't have to be reactive, we have to be proactive using these predictive models. So that's a whole motivation behind this paper. So for this, we leveraged, we're proposing a couple of A and ML modeling for this. I can go through that in next couple of slides. Yeah, as I was saying that if you keep the cities, and be using this AI, it impacts in various other dimensions of entire our life, right? It's not just city, it can extend to various other domains, like like our living environment, or it will even help the government, people, the various other sectors I mentioned here. So the impact is huge. That's what I'm trying to explain here. So we do have advancements in AI, and we are actually using that in some areas already, but we're still not leveraging the generative AI, which is like huge from last couple of years actually, that so people are using more Bird and all the GPT models and all. So we should leverage the generative AI more to have this predictive modeling instead of reactive modeling. So I referenced all these literature reviews on the various papers. So most of them are a great job on, but they're not actually leverage the Gen AI. But a couple of them mentioned, especially the second one from Brown, and the fourth one from Fernandez. They're kind of started using, but I developed this paper research on top of that, enhancing what they're saying. But the idea is to leverage the generative AI to solve the problem. So the gap analysis, like I was mentioning, right? So as of today, most of our city or even any of our government policies, so most of our reactive stuff, not predictive or proactive. I would like to give a couple of examples on each category. For example, in the traffic, I already gave, right? If you can know that this signal has, or this junction has too much congestion or too much traffic on, so you can build upon, I know you can take a proactive decisions without waiting for having 100 number of accidents there. That's one example of traffic congestion. And the flood map, right? Let's say that you need to provide the flood whenever you actually having flood in cities. You need to have a real-time monitoring using satellites, right? Let's say this area is more prone to the flood next 12 hours or something like, so you can alert the users in a real fast way, instead of that gives the window up for them to move away from that place. That's a natural disaster stuff. So yeah, in various crime, right? So we can definitely have the data. We can gather the crime data of the city, right? Like, for example, some ABC city has more crime than XYZ, but this is more having more advanced information or more real time instead of like usually the data we collect is manual audit, all this stuff. So like say from 20 until 2020 until 2021, right? It's always lag behind the actual thing between now and actual data. So this predictive thing and having the automation of getting this data continuously and in the real time, so that can help the actual users take the informative decisions. Let's say if I want to move to some certain city with my kids, is it the right place to move or not? That kind of decisions help the community to take a better decisions. So all these kind of things we can achieve by having this generative AI modeling on the cities in various categories that I mentioned. Those are just few examples. We can extend this to further, but these are the gaps we have with the existing AI stuff. The methodology is very straightforward, like what we have seen in other papers, right? The collection of the data, right? So we get the collection data from the various sources, the surveillance footage, sensors that we use for traffics, the satellite data that for flood mapping I mentioned, even sometimes we are heavily using social media these days, so we can leverage the social media feeds as well. Especially my city where I come from, like they have a social media alerts. Whenever they have some road 121 is blocked, they will get an alert immediately before I can go and actually have it. 121 is blocked with some accident or something like that, so that it can save our time, or we don't have to be stuck in the traffic or something like that. So, and once we have all the data available, then we need to process that data for extraction of, based on what actually you want. And then the modeling comes into the picture. Then we are using two GANs and VAEs for this finding the risks ahead of the time, and also finding the anomalies, especially with VAEs. So, and the training, yes, we need intensive training data sets for historical data to make informative decisions. So to have that adaptive learning from the data. So the deployment is for, like, as I was saying, I already covered all the three examples. These are the three areas that we can improve on. That is not the extensive list, but you can improve on. But the paper is focusing on these three areas at this time. So yeah, coming to the results and all. So we do see 0.89 precision with the GANs, with the 8.84 recall, 0.88 IUC score. For the ways, especially for the traffic management, I'm having MSC of 0.03 and AUC 0.91. For disaster, it's 87% simulation and 24% in prediction. So the highestly, the cybersecurity staff with 94% detection rate and 2% false positive rate. Yeah, even though we have a good data here, but we still have so many challenges, to get this implemented in real time with a quality and the how the data we can get, how much the accurate data we will get, especially around the security and all, which I called it here. So it's not easy, right, to gather the data about some of the things that from the public government thing, right? That is some surveillance in some places, like, we have some challenges to get the data, the quality data. And also how we can process that using the Gen AI to have send the alerts, real-time alerts to the community. So those are some challenges I have. So yeah, so definitely incorporating Gen AI is going to help our real-time monitoring on the making our cities better, along with our traditional AI features that we are using today. So future is, so as you're saying, like, it's very, we have so many challenges to integrate to the real data and sharing that to the community. So that is where we can focus on to have a more accurate predictive results. Yeah, that's about it. Thank you.
Anything that was like making super relevant topic, especially predicting a lot of these problems like cybersecurity attacks and disaster preparedness. I was wondering, like, when you look at these models, like, which are using general AI versus like any time series or any benchmark accuracy rates, and like I think disaster predictiveness was like 87 or 85%. Like, what are you seeing in the market? Like, so what are the benchmarks in the industry essentially for error rates and simulation accuracies?
Yeah, as of we're doing this research, these are the two models giving the highest percentage. But as you know that every day, like, we have too much competition on the models, right? Everybody's like top folks are, releasing their models every day, like, deep research came recently, and we have not done taken the consideration of from last 2-3 months of, what they have released. We have not tested that, but this is the best two frameworks that we came with the highest predictive stuff when compared to others what we have. So I don't have a table for that, but these are I don't want to, I don't have the table for all the comparisons, but I should have some there in the paper, but I have not in the slide. Yeah.
This is great. Love to sort of read the paper when
Any other questions? Yeah. Do you have any safety net for any false biases or false positives?
You said safety net?
Any precautionary measures for false positives?
Yeah, as you see that, so this is not like a very critical thing, right? Like, it's not like life or, so I think we have some bandwidth of having the false positives and all. But if you see that those false positives are, reasonably less, right? Let's see the 2% in cybersecurity and, like 0.16 on the crime prediction and traffic management. Yeah, that's what there is still potential to reduce that even further, close to the, zero. But with what we have it, I guess, but we definitely have potential to, keep it close to zero with the advanced in Gen AI models that we're coming up from various other big companies like, Microsoft, Amazon, all this. So we can do that. But for now, I think, yeah, we don't have anything. But the precautionary wise, I think we don't have anything called out in the paper for the precautions. But cities can use this data to take the proactive decisions, like, the traffic management or anything, so that they can take a decisions on the construction of the roads or, having an extra signal on the junction, something like that. Yeah. Biases, I don't think we find a significant bias in these models based on what we have. But I don't have the number for bias here. But yeah, that's what I'm saying. So even if find a bias there, it is something we can take on, right? This is not going to, it's not like, on the like Ms. Agrawal showing like on the cancer detection, like having the scan, MRI scan on those are very critical, right? The false positives has to be close to zero, because that is something like, affecting the human, right? In a different way, right? So we are not focused on that, whatever the aspect of bias and false positives, we're not focusing on that, rather than we are helping to the cities to adopt this, regardless even we have a bias or not. But did I answer your question? Yeah. Yeah. Sure. Presentation. Yeah, data security wise, I was thinking of when I was sharing the surveillance data cameras, so that only should be accessible to the police department or with some city government officials, right? So having this, I mean, when I say the data security and all, I was having challenges to get this research done, right? On that perspective, I said data security, but that is not the critical data, personal PII or HIPAA information, right? So when I said the data security, I was saying to do the research and to make these improvements, then we're having challenges to get the data from the city, right? That kind of, yeah, yeah, thank you. Yeah.
This next presentation is paper ID 117, titled Real-Time Carbon Footprint Monitoring and Predictive Reporting Cloud Solutions for Sustainability.
I think we did do something. Yeah, thank you. I would like to continue with the other presentation, which is I have the same co-author. We worked on this one because it's very relative and similar to what I have been doing that with other smart city thing. That's why we're doing the both are parallel, these two research. So this is about real-time carbon footprint monitoring. So you have, I think you guys have seen in the airports or in the websites and all. So we are targeting like 0% carbon removal from all the airports, and maybe even in the companies like Amazon, or they're going to announce you like by 2030 we will be reducing the carbon footprint by 25%, 30%. The reason is like we are seeing the global warmization and all these things, right? That is in future, right? We should be very cautious in next decade or so to keep that the carbon footprint less, even though advancements in various other things, like we have too many vehicles and too many things we going on that pollute the environment. And also it's an I would say that that should be in the top one of every industry, every business, to have that concern about the environment is the highest priority for everyone to considering, like next generation future, right? So that is the motivation behind this paper. So to coming to the introduction, right? So these are the industrial activities causing the most of the carbon footprints, right? Like how much we're using for the actual vehicles or aeroplanes, or the factories that generate that all the carbon stuff, CO2, all this thing from the industries and all. So everybody has to be, that's where the actual the carbon is producing from, right? Global greenhouse gas emissions. So whatever we are doing so far is like everything is manual, like traditional stuff. Carbon assessment is doing periodic way, like every quarter, every year, something like that. And we are responding to that. Industry or the government is responding to that in a periodic way. So the motivation of this paper is to have that real time. Whatever the carbon footprint we are having has to be real time, so that we can have informative decisions on demand instead of waiting for a long time. So again, the integration of the tool integration is with the same thing, like AI, AOT, and cloud. So AOT is for sensors, AI is for predictive modeling, and cloud is for scaling the stuff, like to store the data, or you should not keep this in the local data centers, but you have to be keeping in the cloud to make it scalable. So this is the two tech integration we need for this research. And so basically idea of this research, I should be going in this next slides, is we need to forecast the carbon footprint for next few years, right? So that we can take proactive measures now, instead of we go and have the problem in after 5 years. So that is forecast. How accurate our forecast is a question here. So that once we have these proactive measures, so industries has to enable those sustainable practices across all the industries, so that we can have a control on those carbon footprint. So we have literature here, like worked on various things using AI, but none of them are working on the real-time monitoring or the real-time usage of this data. So that my research is based on these four literature, especially on the number 3, Rajan. So he's using LSTM. So that's very long short-term data. So I will be using definitely that one to make this happen. So this is the gap. Like I was saying, we don't have a predictive capabilities of forecasting of this data. So we need to get those data first and have the predictiveness going on our data set, so that we can forecast the carbon footprint. So for that, we have to integrate the AI and cloud. We have a very limited services at this time. And the scalability issues as well, right? Very few of them are moved to the cloud, even though the cloud is a long-term thing from last decade or so, but very few of these researchers which I went through was having the scalability issues. The solution is the cloud, but that's what I included in this our research. It's data security and privacy concerns. So because this is where the problem is, right? If any of the research or any of this data hosting in the local, there is no security issues. But if you can share your data, whatever, for example, airline data, right? They don't like to have their data, whatever the data they're having on their internal, to be present in the cloud, right? They don't want, because that's their data. So they always have questions or concerns on the security side to host the data in someone else data centers. So that's anyway there in the cloud. That's a gap we have. So the methodology that used in this research was gather the data as much as we can using IoT sensors, and that data has to be continuously monitored, captured, especially the CO2 and NOx for emissions. The processing, once we have the data, we need to be processed in edge devices for real-time monitoring using cloud platform like AWS or Google or Azure, something like that, cloud storage as a platform. And then we can use the data set to have the predictive modeling using LSTM time series forecasting, so that using this LSTM, so we can provide the real-time data capturing and monitoring, so that we can have the proper accurate forecasting. It has to be faced. The first, we have to be sensor, and then we have to move to the cloud, and then we need to use AI tools like LSTM and other tools to actually, share the forecasting. So the performance, again, LSTM won the race. Like it has a more accurate prediction with the 94.7. And I think if I remember correctly, the second highest was 88 or 87 with the others, but LSTM is having significant difference from other models. The anomaly detection rate is 98.2 and false positive is 1.6. And the system efficiency, I have it here 1.3 seconds per processing, and the energy consumption is this is based on the 10,000 readings, and I'm having the number 0.48. The challenges identified, the quality of the data that sensors were producing for the carbon footprint, right? Because we don't know how much what they're using, right? They say like, my carbon emission is only 20%, but it depends on what device you are using, right? If I use a good device, if it's not using not that good device, that numbers are not comparable, right? Apple to apple, right? So that's the challenge here. We need to have accurate sensor details. That is one of the challenge we identified. And infrastructure costs, of course, if you're using the cloud, it's very expensive thing. So to store your data, right? And the privacy, as I already touched upon that. So you have to have that. Most of the cloud providers have that guarantee to have your data secure. So it's not a concern, but it is still have the, the in perspective of the consumers, they still have the data is not in their on-prem, it's storing it somewhere in the other data centers owned by some other XYD. So that is the one thing that, people are not willing to share the data. So these are the three challenges we identified. So as I say, accuracy, the LSTM is 98 and the other one was like 88, ERIMA. So anomaly detection is close to 100. Like it's very good to find a detection rate. The conclusion, so we want to go away from the periodic editing of the real-time carbon monitoring to real-time, which is like, very proactive emission management, so that we will be ahead of the time. So we will control all the carbon emissions so that we can reduce the carbon footprint in next 5 to 10 years. That is the overall goal of this research. The future work, we can enhance the data security so that consumers will be happy with their whatever the concerns they have. So there should be hybrid models to, even though the data keep in their on-prem, but can leverage the cloud wherever they want. That kind of hybrid can help us. And also we need to deploy these strategies based on the industry. It's not like one deployment strategy work for one, but it may not work for the other industries or something. We need to have a granular, fine tuning deployment strategies for each. Yeah, I think that's about the real-time carbon footprint. So data is what is available in the public. I got the public data sets. Carbon footprints. I used, honestly, Amazon Web Services website to get those data for AWS itself, because we have a data. I work for AWS, so we have a huge data centers. Like that's one of the largest data centers we have. The publicly available data I used. I'm not used the private data, but I used the public data to have this model for data centers. So yeah, whatever the publicly available data, I use that as an error. But I feel like that is itself is a big one, right? Because you know that how big AWS cloud is, right? Yeah, that's what I used. Yeah.
Any other question? So how is it different than any other model currently in research?
Yeah, as I was saying, right, it was most of the research is done on having the periodic assessments, not on the real time. So this research, how this research is different is it is focusing on the getting the data on real time, continuous carbon footprint capturing, CO2 and whatever the things, things. That is a big difference between the other research that we have so far than this one. So that is big difference. It depends, right? It depends. As I was saying, that one of the challenge we had was sensors, right? What sensor you use versus what sensor other provider or others use. We don't have any standardization on the sensors, right? The readings and all. But whatever we have now, we need to make it standardized on the sensor data first, and then we can have a standardized on the readings. Then I think it's not like a 1 year, 2 year things. It definitely takes time, like 5 to 10 years. The idea is to reduce the carbon footprint by maybe 2040 or 2035. It's a long-term thing, but it is a process has to start now to see the impact in next 10 years. Yeah.
Now I'd like to welcome Dr. Garima Agarwal to present a paper ID 305, Image Text to Text-Based Multimodal AI using Florence 2 for remote sensing application.
So good evening, everyone. Good evening, everyone. Myself, Garima. And along with Kunal, I'm going to present with this paper, Image Text-to-Text-Based Multimodal AI using Florence 2 for remote sensing application. Kunal, are you here?
I'm here, but the slides are not visible on the Zoom.
Now it's visible?
It's not visible.
It's not
stuck
visible on
somewhere.
Zoom.
It's stuck.
I'm on the first slide, Kunal.
It's stuck. It's like a loading blank screen, is it?
Okay, so I'm moving it and
you
you
share-
carry on with your... Pranay sir, are you able to see my slides? Pranay sir? So I'm just start with the presentation.
Please.
So this is a work that has been done by Kunal, and I was a co-author for this work. Image text-to-text multimodal AI using Florence 2 for remote sensing application. In this work, basically, remote sensing. First of all, I want to describe that what exactly the remote sensing is. It's a process of detecting and monitoring the physical characteristics of an area from a distance, especially by UAVs or satellite or aircrafts. Special cameras collect remotely sensed images, which help in researchers to sense the things about the Earth. Nowadays, remote sensing is widely used Nowadays, remote sensing is widely used in environmental monitoring, disaster management, agriculture, and urban planning. AI is used in many remote sensing for various tasks, such as area and size estimation, estimating the area covered by the given input or size of an object. It can be used for object detection of various objects or natural features present in the given input, such as water bodies, buildings, green belts, etc. Detecting or tracking the changes observed over a long period of time. Also, AI is used in efficient planning of land usage for cities, and it is also used for making better response plan and disaster mitigation techniques. So what is the problem that we have seen with the existing solutions? That remote sensing is a complex process and requires sound training and technical knowledge. So it has become difficult to take full benefit of remote sensing applications because of the number of trained professionals are very less. And for this reason, it becomes further difficult to scale these solutions. So further problems such as human bias and inconsistent data make it difficult to use remote sensing for solving the increasing need of modern industries. So in this study, what we have done, we have extended the application of visual question answering to remote sensing. It is the technique where AI model answer users question based on a given input image. So this application basically gather the data about Earth via satellites or drones. AI enable tasks like object detection, area estimation, and change detection. But problem with that it require need for skilled experts, inefficient resource usage. So the proposed solution that we have come up with, VQA, that is visual question answering, that is multi-model AI that allows the users to ask questions about the images in the natural language. The benefits that it is easy to be handled by non-experts, it is scalable, and comparison. And in this study, we have done comparison of popular models like Flamingo, Blip2, and Cocoa also. These are the various commonly known VQA models, and we have done on Florence 2. Florence 2 highlighted for its compact size because of the dual attention and vision transformer. Low computational requirements for this Florence 2, we have find out. Cross-model attention, we have used the concept of transformer-based decoder, and we have used RSVQA dataset, which comprises of 10659 satellite images, and we have given question answer as a pairs also. And the image size was 512 cross 512, and we get text embeddings from transformer encoders, and we get output as token. Now I want to hand over further to my fellow author Kunal to describe the architecture for Florence 2. Kunal, over to you, please.
So in Florence 2, it's comprised of several different models. First one is David. It's a vision encoder which is used to generate image embeddings from the input image. Then it has a BART style tokenizer, which is used to generate tokens from the input text. Then these tokens and embeddings are passed on to transformer encoder and further to the transformer decoder, which uses a cross-model attention to introduce multi-modality in our whole model pipeline. And finally, the results are again processed back to the natural language and given back to the users. This architecture is very lightweight as compared to other famous open source models, which are mentioned by ma'am earlier. This model that we have used comprises of only 0.23 billion parameters. Moving on to the fine-tuning parameters, we have used a RMW optimizer. We have set up the learning rate to 10 to the power minus 6 and a linear decay scheduler for the optimized results. Further, we have set some parameters such as batch size and workers based on the hardware limitations we have. Now, the next slide shows the accuracy versus epoch curve, which basically shows our model's performance after each epoch. And we have used metrics which are accuracy, we call F1 score, and precision to evaluate model's performance using the RSVQA HR dataset. For the evaluation purpose, we have used a 70-30 split. Now, the next slide shows compares our model with the existing works that have been done earlier. The table on the left side compares the average accuracy of different VK models that have been trained on RSVQA HR dataset. As we can see from the table, our model has achieved average accuracy of 96.04%, which is very different from the earlier results. Further, the table on the right compares our fine-tuned model with the base model, and we can see a rapid increase in the accuracy after fine-tuning. The next slide shows a simple deployment pipeline for our Florence 2 fine-tune model. The diagram shows how one model can be deployed to different platforms, can be accessed via local device using CUI or GUI. Further, it can be deployed on a cloud platform, which can be used which can be accessed through a user application. It supports multi-channel inputs. That is, it can take images from drones, satellites, and aircrafts. Handing over back to the ma'am for concluding the.
Thank you, Kunal.
Thank you so much.
Thank you.
This is personally super relevant for me because I work for a satellite imaging company.
Oh, great.
And like one of the major issues that we face is like a lot of organizations cannot buy because they don't have GIS analysts.
Right.
That's relevant. So big organizations buy, small ones don't. And we're trying to essentially incorporate models like we're trying to incorporate like LLM models into our workflows.
Oh, great.
For itself, so that they can like we can open this huge market of smaller and medium commercial organizations that can start buying our product. So really looking forward to this paper. Thank you.
Thank you so much. And we will surely take help from you also to extend this work.
Oh yeah, absolutely.
Yeah.
Happy
Thank
to
you.
support.
Thank you so much. Any other questions, please? So thank you. Thank you, everyone. Thank you, Kunal.
Thank you so much. Thank you, ma'am.
So next we have with us next author who is going to present his paper is Hassan Hashmi. He is going to present his paper on influence of voltage harmonic spectrum on no load losses in power transformers. We welcome you, sir. Sir has joined.
Hello, can you hear me?
Yeah, you are audible.
Okay, so let me share my screen and begin my presentation. Okay, I hope you see my presentation as well.
Yeah, we can see it. We can see it.
Okay, so in this paper, we are going to talk about the influence of voltage harmonic spectrum on no-load losses in power transformers. I'm Mohammad Hassan Hashemi with Research and Development Department of El-Taş Transformers, with my colleagues Hüseyin Polat and Seda Güven Başaran. Transformer is a static device that transfers electrical energy between two or more circuits. This device uses a magnetic induction principle to change one voltage level into another voltage level with keeping power frequency and total power transferred unchanged, constants. Also, transformer is one of the most efficient components of power system, and it is very critical component as well in terms of its cost and its functionality. Transformers serve as critical component within power grid, facilitating the transmission and distribution of electrical energy. The devices play an indispensable role in power system, enabling voltage regulation, impedance matching, and isolation between different parts of the grid. To understand the importance of transformer is very critical for engineers who design transformers and also the utility companies. By popularity of renewable energies such as solar energies, we use transformers in solar farms more and more. The solar farm is connected to grid forming converter, which uses the DC voltage into AC voltage. And then by using transformers, it transmits the electricity to the main grid. There are two main types of losses in the transformer core. The first one is the eddy current losses, which happens in transformer core, which is a function of the frequency of the power system and also the thickness of the laminations in the transformer core. And the second one is the hysteresis losses of the transformer, which is a function of transformer's frequency and also the quality of the material used in transformer cores. In general, transformer core is made of cold rolled grain oriented steel. This kind of steel has some percentages of silicon alloys, which makes this kinds of material very permeable. Its permeability is high in electromagnetic and magnetic fields. A conventional way to calculate the losses in power transformer is the use of a specific no-load loss curve. This curve is given by the core material manufacturers, and it is a function of its thickness. Here we can see different material types and their no-load losses in transformers. In this study, there are three scenarios. The first one, when we have no harmonics in power system. The second scenario, the second and third scenario, which the first and second scenarios in terms of analysis, we have harmonics in the grid voltage, but they with different harmonic spectrums. The study is done using finite element analysis of ANSYS Maxwell. Here we see that the 2D model of the transformer and its meshing on the right-hand side. In the first scenario, we see the harmonics of the power grid in the 3rd, 5th, 7th, 9th, 11th, 13th, 15th, and 17th harmonics. And here we see the total voltage spectrum of the grid. In the second scenario, we only have 3rd and 5th harmonics, but the total harmonic distortion of the first and second scenarios are the same. After the analysis, we calculate the hysteresis losses and eddy current losses. Here we see the eddy current losses for scenario 1, 2, 3, and when the red one when there is no harmonics in the grid. Then calculation of the hysteresis losses happens, and the sum of hysteresis and eddy losses are calculated finally. The results show that when we have pure sinusoidal voltage, the losses, both hysteresis and eddy current losses, are less than scenarios 1 and 2 when harmonics are present in the grid. However, the losses in scenario 2, which we have only 3rd and 5th harmonics, are less than scenario 1. The findings of this study demonstrates that when we are ordering a transformer into our grid, not only giving the harmonic total harmonic distortion is important, but also we need to provide harmonic spectrum to the designer and manufacturer, because it has a very significant influence on transformer losses and finally the final lifespan of the transformer. At the end, I would like to thank Eltaş Transformers and TÜBİTAK, Turkey's Council of Education and Research in Turkey. And if you have any questions, I can have you answer your questions as well.
Thank you so much. Any questions? Students, any questions? No questions for you. Thank you so much.
Thank you for listening.
Thank you.
Thank you. Thank you, Hassan. Thank you, Hassan.
Thank you, sir.
We are left with the last presentation for the day. Shaurya Pratap, are you here?
Yes, ma'am.
Anjali? Shaurya, slides are visible to you?
Yes, ma'am.
Okay, thank you. So very good afternoon, everyone. Shaurya Pratap Singh, along with myself, Dr. Garima, we are going to present a paper on deepfake detection using CNN-based architecture. Deepfakes are hyper-realistic fake media generated using AI techniques like GANs, right? Generative adversarial networks and autoencoders. While they offer creative opportunities, but seriously, their misuse poses serious threats ranging from identity theft to political disinformation. Traditional detection methods can no longer keep up with the pace of deepfake technology. This is where convolutional neural networks come into play. They excel at analyzing subtle pixel level inconsistencies and making them ideal for deepfake detection. Generative adversarial network involve two neural network, a generator and a discriminator, competing against each other to create increasingly realistic media. Whereas autoencoders compress and reconstruct the data, learning key features of the real images and using them to recreate or manipulate faces. CNN-based models become the backbone of many deep learning, deep fake detection systems used by social media platforms, government agencies, etc. These are the basic gaps that we have found out in deepfake detection while during the literature survey. Deepfake detection faces several key challenges. First, the realism of modern deepfake make them hard to catch using traditional methods. Secondly, new generation techniques evolve fast. Methods that worked last year may fail today. Real-time detection is also tough due to heavy processing need of high-quality media. On the top of that, many dataset lacks diversity, causing models to overfit or miss certain forgeries. And finally, adversarial attacks. Tiny manipulations are designed to fool even advanced detectors. So these gaps highlight the need for smarter, adaptable, and resource-efficient solutions. So in this study, our main objective was to design and compare CNN-based models for deep fake image detections. We chose CNN because they are highly effective at capturing spatial features in the images, which is crucial for spotting subtle manipulations in deep fakes. The three models were selected based on their proven performance in image classification tasks and varying complexity, helping us explore the trade-off between accuracy and computational cost. To ensure fairness and consistency, we trained and validated all the models using Face Forensics Plus Plus dataset and a widely recognized benchmark in this field. We then evaluated each model using standard performance metrics to identify the most efficient and practical option for real-world deployment, especially on the platforms we are facing increasing threats for deepfake content. CNN excels at analyzing the visual data. CNN helps to visualize the data at pixel level analysis. Minute anomalies at pixel level can be seen. Feature extraction automatically learns complex patterns from the data. Hierarchical learning, where CNN learns visual features in layers. Temporal analysis, when extended with temporal layers, like in 3D CNN or with LSTM units, they can track inconsistencies frame by frame, such as unnatural head movements or flickering. So now over to you, Shaurya. Just cover up the architecture or the methodology that you have followed while designing this architecture.
Thank you, ma'am. So for the methodology, we have used the face forensics dataset, which has 50,000 images, half real and half fake, generated using GANs and autoencoders. The images were resized to 224 by 224 and normalized for consistent and efficient training. Data augmentation techniques like flips, rotation, and brightness shifts helped improve generalization. For modeling, we designed three CNN-based architectures: a lightweight 3-layer CNN for speed, a VGG16-based model using transfer learning for balanced performance, and a deeper ResNet 50-based model, also using transfer learning to capture more complex patterns through residual connections. Our custom CNN had 3 convolutional blocks, followed by max pooling, 2 dense layers, and a sigmoid output to predict whether the image is real or fake. Transfer learning helped us leverage pre-trained weights, reducing training time while improving accuracy. We trained each model for up to 50 epochs using binary cross entropy loss. We used the Adam optimizer because it's adaptive and well suited for image tasks. Early stopping was used to prevent overfitting, which is that the training stops whenever the validation loss doesn't improve for 10 epochs. For evaluation, we look beyond accuracy. Precision shows how many predicts were actually fake, and recall tells us how many actual fakes were detected. And the F1 score balances both, which is important for the real world scenarios where the false positives and negatives can be costly. We implemented everything in Python using TensorFlow and Keras. Training was done on NVIDIA Tesla V100 GPU, and it took for more than 4 hours. Now we'll come to the results. The ResNet 50 model achieved the highest accuracy at around 96.8%, followed by VGG at 95.2%, and our lightweight CNN at 92.6%. ResNet's deeper architecture made it highly effective at detecting fine-grained manipulations, while VGG offered a good balance. The lightweight model, despite being less accurate, promised a good speed and efficiency, which was ideal for devices with limited computational power, reliable across different performance dimensions. We'll now come to the analysis. ResNet 50 gave us the best result due to its residual connections, which allowed deep training without vanishing any gradients, and also helped us detect subtle deepfake clues like blending artifacts and unnatural lightings. The lightweight CNN was fast and efficient, but it lacked the depth to learn complex facial forgeries. VGG offered a balanced performance. It's deeper than the lightweight model and benefited from the transfer learning, which improved generalization. All models had strong F1 scores, showing a good balance between precision and recall. We observed slightly more false positives, likely due to the noisy real images. In general, deeper network improved detection, but required more training time, which we addressed using the dropout, weight decay, and the augmentation to prevent overfitting. Now we'll go towards the findings. We observed that the lightweight model learned quickly but plateaued around 92%, whereas the VGG achieved a smooth rise in accuracy to 95%, showing strong generalization. ResNet had a slower start, but it peaked at 96.8% after 30 epochs, effectively capturing deepfake details. These patterns confirm that the deeper architecture yield better results at the cost of longer training and higher computation. The confusion matrix of our best performing model showed high true positive and true negative states. False positive states were slightly more common, where the real images were classified as fake. They were likely due to the natural artifacts like lightning or noisy images or compression. Overall, the model was highly reliable in separating real from fake images. Now that we've discussed our results and analysis, we'll be talking about the implications and what the future scope would be. Our result shows that the CNN models can reliably detect deepfakes with over 95% accuracy. That's huge, especially as deepfakes are getting more advanced and realistic. The lightweight CNN model is particularly useful for real-world use in mobile apps or devices like phone, webcams, etc., where the quick detection is needed. On the other hand, whereas the deeper models like ResNet 50, they are well suited for forensic or enterprise level applications where higher security and accuracy is more important than speed. Overall, the system can contribute to building trust in automated biometric verification, online content validation, and even help in digital forensics or legal investigations. The future scopes would be as follows. We would want to improve the model's defense against adversarial deepfakes, which are designed to bypass the detection algorithms. Another exciting idea is to develop a cross-platform API or browser plugin that can scan and flag deepfakes in real time, for example, on social media or video platforms. And finally, training on multi-model datasets, not just images, but also audios and videos, which would allow us to handle even more sophisticated deepfake types that will be happening in the future. With the deepfake evolving rapidly, regular model updates and robust detection system like ours will be essential in protecting users and preserving digital integrity. That brings me to the end of my presentation. Thank you so much for your time and attention. Over to Garima ma'am.
Thank you so much, Shaurya. Any specific questions? Okay. Yeah.
Again, that's being open. It's actually still like in the interest of these larger organizations and social media organizations to not detect deepfakes. That's why Facebook does not do it. Twitter does not necessarily do it except out of community notes.
Right.
So any Chrome extension or something like that is pretty helpful, especially for my parents and for me as well, honestly, in the future, because we won't be able to tell them apart. So if you're working towards real time, like a real-time app or a plugin, that's awesome.
Thank you so much. Thank you for your feedback. Thank you, Shaurya.
Thank you, ma'am.
Thank you so much.
Thank you, Shaurya. Thank you so much. So with this, we come to the close of this technical session. I extend heartfelt thanks to all presenters, session chair, and all my students who are listening it patiently since today morning. I'm also thankful to Mr. Archit Jain. Thank you for being the session chair with us. Students, you can also interact with him. He's a very good in data science. He's enthusiast. He's a good strategist, and you can take his help while for your internships, while getting some ideas about your research topics, and that would be again helpful for completing your BTech degree. So thank you so much for joining us. Thank you, Pranay sir.
Thank you. Thank you. And I
Thank you,
compliment
Pranay, sir.
you and your team for conducting 12 hours.
Yeah, you all please come here and just show that everyone is here. You all my students, please
Dr.
come this
Agnish.
side. Pranay sir, she's Anjali. She's coordinating with
she
me
did
all
it
the
very well.
sessions.
I saw her
Yeah,
yesterday.
Shaurya, Shaurya, please come.
Yeah.
Shaurya, Ankur,
Shaurya.
Ankur is here.
Well done.
So they all are
Well
computer
done, well
science
done.
engineers, and they helped me a lot while conducting 2 days presentations.
Definitely. They
And
carried
really,
on.
thank you so much thank you so much for your patience, because you are still awake. Really thank to you and for giving us this opportunity. Thank you so much.
Thank you, sir. Thank you.
Welcome. Welcome.
Akriti, yeah, please. I forgot Akriti ma'am, but I can't do that.
Akriti, I heard her name. Yeah. Yesterday she was there.
Akriti and Kansh, they are also helping me a lot. Yeah.
Well done, boys and girls. Well done.
Thank you so much, sir. Thank you. Thank you, IT team, for supporting your help and giving us
Mobin,
complete
thank you
IT
very
support.
much.
And without your support, it would never be possible. Thank you so much for being so late in night. Thank you so much. Mobin sir, are you here?
Yes, ma'am, I'm here.
Thank you so much, sir, for extending the support. Thank you.
You're welcome, ma'am.
And we can close the session now.
You can close the session now.
Okay, thank you, ma'am. Thank you, sir.
Thank you, Balu.
Thank you so much.